Namaskar, good morning, good day, Sat Sri Akal, Assalamu alaikum warahmatullahi wabarakatuh. This is Yasura Singh speaking from Bharat, India, to all my friends around globe, and July 26, 2020, and a critical day of life, and in connection with profession, particularly profession of engineering, profession of civil engineering, construction engineering, design engineering, all that, whatever covered in profession of civil engineering, that's all, and various other issues which are directly into engineering management, engineering world, a world without which nothing can move, nothing can happen, and on top of that, super criticality of world, like corona, that is headache for everybody, but not headache for corona actually. Corona, on head of all, you can say, it's has become crown of world without world acceptance. Crown of world without world acceptance, but doesn't accept is a crown, a super crown, it's crown, exclusive crown. Nobody can do that. Such a powerful entity has come. So what should I say about that? It's for everybody to understand, to realize fact that whole world is in script. No way to out, no lost from here, no way lost, no way at all. We have to live with this, no other way out. And we talk of management, we talk of management, engineering management, and we talk of materials, which you can say like that, in simple terms. I'm talking of this, management, probably FIDIC at time, and concrete of course, so useful in general, and soil in specific. Soil in specific, because soil is very different. If we fail to understand soil, we fail to understand everything. And of course, 19 January, that is, what you can say like that, or I can say, whatever word you can say, it's all that. This is, in fact, January and to continue with this outside, also little different, little naming, titling in just a way, something as usual, a few minutes absorbed on that as usual we do. This is I call engineering, management, systems, changes, organization, challenges, human thinking, only resort, general, specifications, general materials, total systems, quality, structured, quality structured soil engineering, and reports in FIDIC, etc., whatever we can, we will do again reversely for FIDIC, reports, soil, and structured, quality, and systems, and total, and specifications in general, and resort only thinking and like that, and organization, management, systems, all that are covered in including corona. Possible to talk about that. Yes, whatever is possible, we can talk. much time we have. We can talk stuff all, no issue at all. No issue at all, and whatever we can. I'm not saying we'll talk a lot in that, or little in this. So let's start. After tidying this, now move on to. I'd like to start with little different, and I yesterday spent a lot of time and talking about soil, and soil is real material in real world. If you do not realize this point, being an engineer otherwise, you miss a lot of reality. I have about more than, can say, keeping well from 75 onwards, or let's say 80 onwards, when I came to real engineering field. Around 40 years if you count off from 81 to now, and this around 40 years, in total experience, I cannot say, varying fields of experience, varying ranges of experience. I have come in contact with, in touch with various problems in construction and designs. And problems are there, certainly. That's why we are there. Otherwise, we are not required. If there is no problem, problems are required to be solved by professionals, and that's where we are there. Otherwise, what's the necessity of professionals? Say, no necessity at all. Many problems life gives you, and because one is qualified, educated in certain field, it's duty of professional not to panic but to do job as it had. Problems are there, and therefore solutions are also there. The solutions are charted out by professionals. It's their duty, and if they are not able to do that, then there's no need of professionals. Professionals are not followers. Yes, they are followers for senior. If senior professionals are there, then junior professionals are required to follow them. But otherwise, they have to lead. Professional means lead. Professional is a leader for those who are in profession. It depends on caliber, it depends on your attainment, how much can you perform, and that performance is unit of measurement of professionals. There is no other measurement. What can you perform is most important, and your performance depends upon what you have learned in your life. Just theoretical and practical both. If you have learned only theoretical, no practical, then you are not nowhere. You are not 100. I can't say you are there. You won't be accommodated. You won't be accommodated anywhere if you are just a learner. If you are just having knowledge without experience, knowledge without a tutorial. So it's very important to be experienced. In civil engineering, civil construction, civil designs, I am from civil, I am talking of civil. There is a misconception of civil. Civil is actually a term only, but this is the public, What is done for public is actually civil. Originally, public, every field of engineering does for public. But civil engineer, because it comes first, it has different meaning. Though civil we say, but actually this is for public jobs, for all jobs, even in army services or in some other services, which are away from people, means we don't have connection with people directly. Those people also use services of civil engineers. Even you can say design and construction of nuclear reactors, nuclear plants, or all other plants, civil engineers are required, because without them you cannot think of anything. So I am taking civil as that. I am not taking just building engineer or road engineer or that. Wherever there is something you will find presence of civil engineers. It is different at what value to call here. In plants, big plants means where billions of dollars are spent on total plant, maybe coefficient cost-wise of civil, maybe little, but importance is higher because first requirement is civil. It is everywhere. Means equipment may be very expensive. Flights may be very, airplanes may be very expensive, but ultimately if there is no airport, building or no runway, your plane cannot work. So one should understand its importance, and if you understand your importance, you can take responsibility accordingly. Otherwise, you keep a factory of mine, I'm not very much required, I'm not given the value in market, so why should I? No. Your value is in our hands. In your hands, value means what? Value means you are indispensable. I mean to say, if you are a civil engineer, you are required everywhere. So you are responsible everywhere. You are accountable everywhere. You have to take responsibility everywhere. That is what civil engineer is all about. And if civil engineer cannot understand this point, nobody can help that civil engineer. All other engineers dominate because you do not understand your value. All professionals who are not from your field, they dominate because you do not understand your value. Your value is in your hand. Don't think that this is job of dust. Yes, it is job of dust. But that dust is life. If there is no dust, there is no life. If there is no water, there is no life. That's also true. It's dust. I am a dust engineer. I am a sand engineer. I am pollution engineer. I am a clay engineer. I am everything silt engineer. You can say that. I am a toilet engineer. I am a urine engineer. Urinal engineer. I am. So what's wrong with that? I am that engineer because I fulfill your very basic requirements. Very basic requirements. You want to pass your urine? I provide urinal. You want to pass your night soil? I provide a WC. You want to take bath? I give you bathroom. You want to walk on a footpath? I give you footpath. You don't want to walk in desert on the rough area because it gives you additional friction to walk. So you don't want to walk on that. You want a path, so I give you a rough road also there. Who gives that? Cylinder gives you that. Question is, you have to understand your basic position. And if you don't understand that, you keep busy somewhere where you are lost for when you just think I'm working for them. You're not working for them. You are working for development, without which they cannot live. So do not underestimate yourself. Do not confine you only to one field or one discipline in your engineering. You are wide on discipline. You are broad discipline. Respect your interdisciplinary work. Don't stick to one subject. Oh no, I am only MS. Yes, that is your field, that is your expertise, but that is linked to other expertise. That's the point here. I just want to bring to attention of every engineer, every citizen, world citizen. I'm not saying that this is because it's a professional work. It's my job. Irrespective of what payment I get, if I have to survive, I have to do that. If I don't do that, I can't be called an engineer. I am an engineer because I work in that field. I have got training of that field. That's what I can do something for society or whatever country or whatever area. I do that. That's why I apply my knowledge, I apply my experience. It may be right or it may be wrong, it may be bad or it may be good, but I have to do that. That's my binding, and this is my basic criteria I call individual organization, individual path, individual lead, and that's what's leadership. I have to lead myself first. For that I should have that thinking. I should develop that thinking. What does my lead mean? Does it mean only design? Does it mean just stick to something? No, that's not my lead. My lead is to lead others. My lead is to lead others and let them lead themselves. To teach them how to go, how to move, because I have my limitations. I cannot go all the way they want to go, but I have to tell them this is your signal, you move on and on. Civil engineer has to analyze first individuality. If you can't analyze individuality, you can't understand whole world, and you can't even identify your true nature, your true responsibility, your true obligation. If you are really interested in learning that, you have to analyze yourself first. Don't think that you are under compulsion or you are under force. First of all, it is your interest, it is your profession. You elected for this profession. Nobody forced you to that. And this profession is having multi-dimensions. Civil engineering is having multi-dimensions. And first of all, let me be clear with you. When I say civil engineer, it includes structural engineer, it includes construction engineer, it includes design engineer, it includes irrigation engineer, water resources engineer, environment engineer, road engineer, railway engineer. Wherever civil activities go on, all those fields include under umbrella of civil engineering. Civil engineer is not title alone, it's a coverage. It's a coverage, you can say. It's entire scope of humanity where some part is given to. Important point is some part is not some part in end. Part, but it is in beginning. It is at number one. When there is nothing, you have to start with scratch. And when from the start with scratch, that's most important. That starting is always very difficult. Starting, what to start, where to start, from what subject to start, how to start, that is always a problem. That you can say making enough decisions there, that's the organization of civil engineering. Make decision, even at low level, make decision. Your decision may be long term or short term, you have to take decision. You have to take decision in designs, you have to take decision. You have to take decisions in materials, you have to take decision. You have to take decision at every diagonal, at every corner of side of a figure, and that is very important point. You should not underestimate yourself, forget yourself, for your examination. That is another part. Think of your work, think of your mind, because it's your mind that is doing civil engineering. It's telling you, you decide to do that. You have various problems, you have to understand problems, you have to analyze problems, you have to find solutions, you have to see what are hazards, what are not hazards, where you are right, where you are not right, all that point you have to understand. Not only you can say that, you can do something. If a civil engineer starts thinking, there's no limit, remember. Civil engineer is only civil engineer until that doesn't think. But once civil engineer starts thinking, then he's not civil engineer, he's a thinker. Civil engineer has to convert to thinker, because civil engineer means thinker. And if you cannot think, then you are an ordinary person. You are just a follower, and follower is not required in engineering. Leadership is required in engineering, not political leadership, not commercial leadership, technical leadership, workers leadership, machines leadership, planning leadership, safety leadership, design leadership, execution leadership, prosecution leadership. All leaderships are required by civil engineers. Civil engineer equal thinker. First thinker in the world is civil engineer, remember. First analyzer in the world is civil engineer. First dirty person is civil engineer. First man is civil engineer. First foreman is civil engineer. Because civil engineer starts clearing jungle, clearing weeds, clearing old bushes, and clearing all that from their dogs' stool, cats' stool, animals' stool, humans' stool, has to scrap out everything. Means that starts there. Right or wrong? You have to walk in desert, you have to walk in dirt, and you have to then create temporary arrangements for people to come and go. So it's the job. It's sacrificial job. You have to stay away of your home. You have to leave your wife aside and don't marry. You have to leave your kids aside, don't marry. You have to stay in some areas where people don't want to stay. You have to sacrifice your comforts if you think these are comforts. If you think, no, my struggle is comfort, my dust is comfort, my sunlight is comfort, my rain is comfort, my everything is comfort, my all of the septic gases are comfort, you are everywhere. You go everywhere, no problem if you think you are simple there and well there. Away from society, because if you are not away from society, you cannot serve society. You are away from society. Keeping away from society increases your concentration because you think forward. You don't have something else, you don't have girlfriend to move around, you don't have something else. And those who don't want to go, they go to somewhere in that type of work. They have to sit there in the office and sit and enjoy life and don't worry about something. Not towards something, and that's okay, that's fine, depends upon choice. But remember, if you have to deliver something, you have to work, and for that you have to sacrifice. Nothing comes to you without anything. Remember, if you don't study regularly and thorough, you can't pass examination even, and then you have to keep away from society, from social functions, from marriage functions, birthday functions, all other functions. You have to keep aside, only otherwise you waste time every day, every week, because you have such ceremonies all time of year. So you use 20-25% time with those, and you waste your time, you can't concentrate. Even if you miss lectures, 1 or 2 or 3 lectures, you miss everything, you miss subjects, it happens with everyone. So time is very important for a civil engineer. Time does not wait for anybody, this is also true, but civil engineer for sure, time is very important. You have to work in sequences, that's very important. It may be parallel, but parallel activities come only when there are sequential activities, the basics of planning. If you don't understand that, you cannot say, I start this activity, I leave it and go to that activity. You cannot do that, I cannot done. You have to move in serial number 1, 2, 3, 2, 2, 2, 2 and 2. You cannot say, I'm at 1, I will go to 9 today. You cannot go to 9 to that ground is not able, the site's not clear, I can do that, you cannot do that. That's a very important point. Time, cost, and your performance quality, and various other factors related to many unknown points, unknown definitions, which may not be in your hand, safety, and many endpoints, which you have to solve, you have to resolve. Everything comes in there, everything's for you. When you see your leader, your initiator in the field of engineering, or to develop society, what do we say in our perform our duties? Engineers duty, what said? Industrial work depends on whom? Depends on engineers, industrial engineering. Factories all depend on engineers. Development of cities also, civil engineers. So civil engineer, electrical engineer, mechanical is a triangle, I can say. Civil, electrical, mechanical, particularly these three are triangle. In one figure, civil engineer alone cannot move. That needs support from mechanical, electrical engineers. At certain point, sometime, somewhere, these three combine together. Because without machines, engineers cannot do anything. It's not 200 years back, we are not here. We need support. We need side generators, we need some support, we need something somewhere. Even if we need cycle or scooter somewhere, we need motorcycle somewhere. So you need some other kind of engineers in that position. Some support you need. That's what I'm saying. Basics we have to understand. Evolution of engineering life you have to understand. We talk of soil was just given few decades back. And I think up to 1950 there was no major science or engineering of soil. It's still very young baby. We do not understand that, but we forget that without soil, engineering does not exist. Soil is basics of engineering, not only civil engineering, every engineering. Because applications or you can say all other machines based on some ground, and that ground basis on civil engineering. I'm trying to explain something which you should understand, because that has been ignored. That has been ignored. I want to fill that gap. It's just not. We always say, we have done this building. It's my building, I've done it. It's my building, I have spent so much money on this. Very good. A client says that, owner says that, government says that, but people say that. Oh, we have smart cities. Yes, you have smart cities. But what is smart in that? Your definition. What is smart in that? Question is not what is smart. This is smart city based on facilities, or otherwise it is smart. If you have facilities, all facilities, you have communication, electrical, you have no problem, you have transportation, everything, that's okay, fine. Question is, what happens when earthquake appears and occurs? What happens? Your city collapses. Your city collapses. Or near collapses. Now, where are your smart cities? Criteria has gone. Your smart city cannot store, cannot protect your building, your city from impact of earthquake. Remember, this is important. Your smart title cannot stop that, cannot take until you understand basic criteria. You are talking of smart city. Okay, I agree. You must have smart city. That is very important. But what is about a smart building? What is about smart structure? What is smart foundation? What is smart everything? Everything should be smart, or only smart city? Question arises. We want to talk superficially, or we want to talk concrete? If you want to talk superficially, fine. You can speak anything. Speaking does not cost. What does it cost? It costs thinking for every part of that work. This is a point you have to understand. That structure, ultimately, everywhere there is a structure. Ultimately, we start, every structure is there. Road, there is a structure. Of course, if you want to construct some infrastructural facilities, there is a structure. Everywhere there is a structure. Of course, it may not be that type multi-story building, but there is some structure in that. In big water line, there is a structure. In big sewer line, there is a structure. Somewhere there is a structure. It's sitting on a structure, some whatever kind of structure. So we have to have a structural understanding about everything. It's not that I'm talking of StatPro or Bentley or something else. I'm talking of ETAP. I'm not talking of that. I'm talking of different structures that gives way to structure over it, facilities over it. If I make a building, this means I need structures, and that is that structure which is there or maybe there, that needs some basis. And if basis that it needs is not worth, what does it mean? It means there may be good structure, there may be whatever we want, everything shall be there, but not durable, not worth. If we do not care of that, generally we do not care of that, generally. I am not saying everywhere. In some cases people are serious, in some cases people are not serious, but it should be, if people had been serious, why should a building collapsed during earthquake or during flood? It happens. Even though what this national calamity, you can't stop it. Yes, it is national calamity, but there is a limit of everything. You cannot just in excuse or forgive or you can say name of national calamity, remove your responsibility. You cannot absolve your responsibility at all. You have to take responsibility because you are professional. I am with every development. I am with every advancement. Every advancement beneficial to everyone. There was a time when there was no calculator even. Right? There was a time in my time itself, there was no calculator. We used to, in my time, I used many times log table. I did not use slide rule because I was not here in my studies that time. I used the log table, I used later on calculator. Computers came only in 80s to public. I don't even say 80s, 90s. So in those days also buildings were constructed, designs were done, drawings were done, everything was done. You cannot say today is specific we are doing. Yes, today is little advanced. We have computer, we have printing system, we have everything system. That is different. Means drawing time is saved, calculation time is saved. I agree with that. But is that enough? Is that enough? Question is that. Today we are dependent on software because we are hardware. Today we don't even care. We just model it. We model it. Now that model is right or not, I can't say. It depends upon the engineer what he does. And then there is just run analysis and run designs, and you got means your answer. So what is your contribution? Your point is that just modeling is your contribution. Means you are just interested in giving something without any further. Means you cannot make sure what result coming is this right or not right, is reliable or not. So there is some part of leniency, you can say. You are adapting. You are not sure because you have different type of education, different type of experience. Remember, until you do something yourself in your life, whatever you do, until you don't do yourself, you cannot understand that. You will attend many lectures, many seminars. You will listen, you will say, okay, yes, but you will not even understand 50% or 30% of that until you do that yourself. When you studied, did you understand what your lectures? Your professor said something, you did not understand thing. Yes, in class it seems I am understanding everything, but when you are off class, if somebody asks you, you want to respond, okay, you write, you are not used to writing. So we have changed everything. My purpose is never to criticize someone. My purpose is always to have self-investigation, self-introspection of ourselves, of myself. If my mind, which I use, is my you can say support, I can take whatever support I intend to have from mind. My mind helps there. Yes, it takes time indeed, but it helps. What's wrong if I use this help for work? There is a stage comes in life when your mind is optimum. You can say this mind is of that level where you can start researching, you can start thinking yourself without any support. Individuality exists there. Individuality is identified there. Identification of individuality. Until you are supported by some guide, some professor, your identity doesn't come into practice until you start thinking yourself. When you come into that stage, that is a significant stage for everybody. You move upward from there. You don't expect others to help you all the time. If you have confidence, if you develop that, if you have you make confident yourself, develop your confidence, and that's really stage, I tell you. There's where advancement begins. That's point of attainment O, attainment 0 or original. That point when you reach, you can say you are a professional. And until then, you can't say you are a professional. And that point is very important part. And that point is everything should be done based on thinking, and every engineer does that. It's good because engineering is that. There can be no engineering without analysis. There is no engineering without detailed analysis. There can be no engineering without understanding meaning of analysis, and if there is some problem, solving those. And that's purpose of analysis. We find problems just like in our engineering. We say we are analyzing structures. It's theory of structures. What I can call that. We find out various forces on various members of a structure. That's what actually analysis is about. We find those forces in every point in every member, from one end to another end, from one node to another node. We try to find out forces in that member, and there are forces in that member, and then we consider then how to protect this member from this force, means how to provide strength in this member so that this force is accepted by that strength, which is called moment of resistance, or some other term you can use to digest that force. That is basic purpose of structure. Whatever structure is there, at whatever height is there, whatever forces are there, we have to keep them intact in one go, and we have to keep members safe from every impact of every action of forces. That is basic purpose. This is basic purpose analysis, to help every member work. That is basic of analysis. And if you understand this point, I don't think you'll find any problem in life which may be problematic for us. That is this very basic point. Means to help member survive. This is what I understand. I'm not making background of my talk. I'm just trying to express my mental feeling. I should not say feeling, mental feeling, because my feeling is not emotionally based. My feeling is logically based. I am creating feeling based on logic, rational feeling, not sentimental feeling. I'm not saying you sacrifice. No, don't sacrifice. Never. But for your work, you have to use mind. And if you want to use mind, you have to work in isolation. Isolation from comforts of society sometimes in life. Otherwise you cannot develop. Imagine when these cities did not exist. What happened? Just imagine. It's difficult for you to imagine, because you are in a time, in age when every facility is available to you. So you don't understand value when these facilities are absent. You don't understand value. There was a time when there was no mobile, only landline. Only landline in every home. And they are not only every home, maybe 10% homes, 20% homes somewhere. Remember that time? What life would have been? Can you imagine that? We have seen that life. We have experienced that life. And also this life we are experiencing. But in end result, I am not finding anything special. Otherwise falling, characters are falling, degradations coming up. Why? Because of carelessness. You see, when you have nothing with you, you have one power, and we have everything with you, you have another power. What happens? If you are short of something, say in life, you are downfall on something, you value that. If I had this, I would have done this. Yes, that happens. If I had this, I would have done this. If I did not have this, if I could understand that, I miss whatever if and what you can say. Had I done this, or would have done this. Everybody has some time in life to think like that. But what you have, you never care for that. That's major point. Whatever you have, sometimes you have wealth, you have your every facility, then you expect more, but you don't care for that. Because when it's for you, oh, this is mine, I don't care for that. When it is yours, you don't care for that. But when it goes away, you feel about that. Oh, it's gone. You try to get back, you find another one, because you are not contented if it's gone. That's what I'm saying. Every engineer has God-given mind. You are engineer. You are not small person. A small person in the sense of mind. Your mind is developed. Otherwise, you can't be engineer. If you are really engineer, you have passed honestly, then your mind is strong, much stronger than all others. Your mind is analytical. Your mind design oriented. Your mind is activation oriented, activity oriented. Your mind is having many directions. Those directions are very helpful to you. And don't stick to one, stick to all. That's what I am talking this because I am talking of soil. Soil, which is very, very strong material, and material where your contribution is zero, is God's contribution. You have not created any soil, you have done nothing to that, you are just going to use that. Other materials, you do at least something, you mine, or you use crushers, or you use something to produce that material. Every material you process, industrial process go on, that all processes, all procedures, you have to pass through that material, then only that material comes to you. But there's only one material which is naturally oriented, natural product, having so much in that we can't even know. And that material is Smurpudanan, because that's only material which supports all other materials. If that material fails, everything fails. Don't consider soil as something you imagine. Consider it that it is there, otherwise there is nothing. Soil. I am talking soil because I am interested to tell you which you have missed so far. It's not because I am giving you something new. It is there, it has been there, and it has been there, even that subject doesn't access that, since then it's been there. Before that's been there. The subject of soil engineering came too late. I think maybe in 1925 or 30s, it started evolving and in 1950 it became to some value, some quantity, and still it's not that much wide. Soil engineering is not that expensive till now, because it's a known world. It's a non-stratification of crust. We know very little about crust, very little about internal part of mantle, and very little about core. We know very little, very little is about. So if you don't know that, how can you deliberate on that? But we know little about crust, and that's why we are able to raise our structures. We are able to do our structures. We can very little we understand about soil. It's very little in comparison to other subjects, because soil we have no contribution. We do not anything. We can't even go down. We have to use some equipment, some machines, some methods. Then we can understand that. That's a very important point in soil engineering. And remember, the soil is like, we don't know actually what it is. It's like our body. We don't know about our body. We only know, yes, we are living. I'm healthy. We say we are healthy because all parts of my body work together adequately, without any pain to me. I don't feel any pain, I don't feel any body stress, I don't feel anything. I feel I'm healthy, and that feeling is that I am healthy because my body is healthy, my every part of body is healthy, and my mind is good, you can say. But even if I feel little pain, I lose my equilibrium. I have feeling pain here, little pain somewhere, and whole my body is impacted. So this is soil body. We are talking of soil body. It's body which we have to understand. What is this body? I'm not saying you understand evolution of this body. No, I'm not talking that. Just to understand conduct of this body, how this conducts, how it's working, outstanding. That's the major part of this. Soil we are using, but what is the soil? From where did it come? We can't say, we don't know from where it come, but we are having this. That's most important. How it was considered, forget that. Nature is there, universe is there, who I can't answer on their behalf. But I can only imagine, I can only assume something, otherwise I cannot say. Something is unknown, which is not confirmed yet. We can, scientists might know something more, at least part of that. Because I am going to use as an engineer, this product, natural product, this, this soil, so-called soil or part of rocks over here. Soil engineering we call it in technical terms. I have observed that this subject is ignored by community of engineers, civil engineers, structural engineers, and all those who use it. And that's drawback in our program, not only in our country but also in other countries, certainly. And when there are some products free of cost to you, I mean free of cost in the sense you are not going to pay for that material, but you are going to only pay to someone for use of land. Means you are just buying land and promoting that for projects. This is happening. Can you cost value of land? Yes, you say I have valuation, I have area, unit cost of this, market value of this, and I can find cost of that land. But that cost is different. I am not talking of that cost. I am talking of something else. Means real cost of this land means internal. When you go down, on surface you don't found something on surface. You have to go down, and it's called substructure of foundation. We work on. We produce that for building support, for building use, structural use, whatever structure, low level structure or high level structure. What's that? And soil is nowhere you can say uniform, nowhere uniform. It varies every day, just like every human varies, and soil also varies. Now, just like every building is different, every human's character is different, nature is different, every country is different in a sense of location, in sense of some other reason, otherwise all are same, there's no difference. All are same. But only, a difference has been caused. So what can I do with that? I can't do anything. Earth is, let us say, 12,500 kilometers diameter body, permanent body and non-stationary body. It's always keeps on moving on its axis as well as in orbital Earth circuit road. We know that much. That's known. Nobody can deny that fact. Yet body is working, and it is working since it was created, and we don't know it's a creative. Now, as an engineer, my job is to make foundation and then make superstructure for whatever purpose, for everything. It's not only for building, for every structure, for every work, you can say, above ground work or below ground work or on ground work, wherever. This means nothing is hanging in air, nothing is in suspension or in abeyance. I put building in air, you use it. Even your flight that goes, your plane that goes in air, it can't stay there, it has to come down. It is landed. It lands. Right? This means we have to come to ground in every case. Or if so, let us make a building which keeps on moving all the time, like Earth is moving, it keeps on moving and moving and moving on, just like Earth is moving. It's possible. It's not possible. It's impossible. Today it is impossible. I don't know what happens after 50 years. You may say, oh no, we have developed technology, your building shall keep moving all the time and you move that. So you will move building over, I can't say. My importance is, my objective is that we have to understand that material which is very important for every structure. That material we do not respect that must be respected, very much respected. And that's called foundation soil, on which we construct our foundation, and that foundation takes superstructure. So simple is that. I don't want to explain just useless words, just to tell you, you should start, you should understand that foundation is important, and because of foundation, structure, superstructure is important that you use. Foundation you don't use for occupation, you use for support of that part of structure, it is used for occupation or use. And because these both do exist together, superstructure and substructure, these two must stay safe on soil, on substrata, or foundation of foundations, you can say. Foundations of foundations. Actually, I should say super foundation. When I say foundation of foundation, means it is senior and senior, it is super. Let me just go this way to relax mode. I don't want to squeeze my legs. So my point is, my foundation is superb because it is foundation of foundations. So you can change terms yourself, because engineers have a right to think whatever they want. Question is, your objective must be there. If I change terms for myself, that's only for interpretation, that's only for analytical understanding. Just so I have to understand meaning of something. There are two ways. One way is that you just understand what meaning is told you, what is told you, this is that meaning, empirical understanding. And other way is you have to logically understand something. You have to understand means title of that, name of that, and maybe that name is perfect one, and that analysis tells you what does it mean. It happens. That's real meaning actually, the real term. I suppose someone is whatever name it has, it doesn't have any relation to character of that person. And if it has got relation with the dull means it's okay, fine. Name is that, character is that. Name indicates character, name is the order. So that way, engineering tells you it's not simply arbitrary name. It has to do working name. It has to do relative name to character of that, to associate, you can say, to attributes of that object. That's why I'm saying soil is foundation of foundation, and this is, you can say, permanent one. You did not do anything on that, it's already there. You just use that, and that soil is allowing you its use. And that's another point to understand. Allowing its use, you are getting service. You are getting service from that soil to which you paid nothing. Did you pay anything to soil? No, you paid nothing. But you are using its service. It's same thing. You are taking sun energy. You are taking sun rays. You are not paying to. You are taking air use. You are not paying anything. It's like that. But it's only joke. Fact remains that soil is serving your building, your structure. Soil is serving road. Soil is serving airport. Soil is serving all plants. Means there is nothing in this world where soil has no contribution. It has contribution everywhere. It has plus and minus contribution. When it spoils air, dust remains in air, its contribution negative one. When it remains as foundation, it's positive contribution. Same particles come out and spoils everything, that's negative role. So we have that understanding. And think of if that foundation, the soil, which I consider as a part of foundation, though we do not take it into our calculations of foundations, except in machine foundations. We can take something in the foundation soil body, we can take some part of soil we take into our consideration when designing machine foundations. But while otherwise we keep, we say, okay, my foundation is not for load dissipation, it's a transfer of my loads, transfer of building loads. We understand that way in civil engineering. Maybe general public understands how foundation is taking load, but we say no, it's just the medium to transfer, because there's a communication part. It's a force communication body. My foundation is force communication body. I am just applying force on this, and this is transmitting to the foundation below, which is very big foundation. And there is no separation in those foundations. It's continuous one for all area, all structures. That's what is actually one. Let us now, this soil which we neglected, we have to understand, we have to respect that. How to respect that? Respect that only by really understanding, by really studying that, what it is, what after all it is, how it was created. We are not going to say creation, we have to understand. We have to understand properties. How, what way it behaves in future, we do not know. But we have to know. That's very important. We know soil is very hard. And it's too hard, it's known as mountain. It's known as rock. And then it's too soft, it doesn't mean anything. It doesn't mean, some people call it peat, some call slush, some call by whatever name, because it has that time no strength in that. It's just like liquid. Just like liquid. Means water, dirty water, you can say. It cannot take any load at time. It cannot take. Because it's very, very liquid. It's flow, it's soft, it's nothing. This means we have to understand capacity of soil. That capacity, how do you understand? And if you find some deficiency in that capacity, can we reinstate that? Can we put some force into that, some strength into that? That is where basics of soil lies in. Because ultimately we have to found our house, our structure on that. We cannot do something else. We are limited, we have confinement, because we have land there, we cannot change it. It's not in our hands or control to change that land. Yes, for a major project we can change location, but for my building I can't change because I have no other land. There's only way that to be. So I have to think that way. My option is limited. The options of major plants are reverse. For my building, for my structure, I have your land. I can't change that. But for major plants, you have no land, you have to first design project and then you have to find lands, or vice versa, both. It depends. And there are options in that. You can change locations, you can do so much. There are so many ways, but that's for major projects. For ordinary areas or small buildings or high rises even, you have no other way out. This means you have to deal with that soil itself, whatever strength it has. We know we don't understand soil thoroughly. Everybody knows it. Just like we don't understand other materials which we are involved in. We produce them, but this soil which we have nothing to do, we cannot understand anything, because there is nothing concrete there. Assumptions and assumptions and assumptions. And like our body is not having exactly same compositions. All compositions, every bodies are different, varying. Capacities are varying, strengths are varying, blood groups are varying, colors are varying, energies are varying, everything varies. Everything varies. Still we are human. Soil, which is nothing other than, it doesn't tell you what it is until you try to understand. It tells you silently everything. And by experience, by observations, we know how many types of soils are there. It's not a books to tell me. We understand that by engineering sense, what sort of soils are there. How we can understand their composition, how can understand their structure. Soil is structure. Soil is also structure, you cannot say no. It's different kind of structure. It's chemical structure, mineral structure. It is having varying structures and not uniform structure. It varies with depth, it varies with horizontal movement, XY axis, and Z axis. There is change. Depends on past history of that soil, that area. sedimentary soil, or igneous soil, or you can say metamorphic, or deposit, or whatever. What is water body with that? What relation water body has got it? How much water body natural water body has penetrated into that soil, or how degradation has taken place, and how continuously it works means they are working, they never stop working. We can stop working, but soil work does not stop working. It's natural. It's a live being, can say, because there's work ongoing. Always there is, they are pure soil. There are minerals in that. There are chemicals in that. There are, you can say, organic matter in that. There are water in that. What's not there? So it's not unit item, clear item, imaginary item, assumed item, pure item. It's a combination of various items. When we have studied, we have gone through. We have to understand that. And if it is deficient in strength, we have to improve the strength. We have to make sure that whatever we do on soil, it should be fit for our structure. That fitness is required, that fit is understood. And if we miss that, we miss a lot. And remember, when soil is ignored and we make structure on that, there is no alternative. There is no solution. We can do only solution. We can solve something before we found on that. If you found something, then you are gone. Then it's your, if you miss soil, you miss a lot. That's why my friendship should be with soil as in first friendship with soil and then friendship with the structure. If I go build, we reverse, then soil, we can't understand. We have to remember, every structure has to work for many decades, centuries, for example, they have to. And long life of structure returns you everything. Take examples of old structures. Old structures, bridges, still bridges, still there. They have crossed hundreds of years, many hundreds of years. Various structures in the world have crossed many decades and many centuries, and still they are intact, or they are retrofitted or restored. This means if soil is given value, I'm not promoting soil here. I'm just reflecting facts. We must understand. Civil engineering doesn't stop at university exit. No. It starts from there. Civil engineering doesn't stop at institution when you're out. No, it doesn't start at a certificate. It started there. Trajagi was not educated, so certified. Similarly, many others, they were not having any university qualification, but we are learning there what they did for us, what they delivered us. We are learning that. So based on such scientists, such qualified people, unqualified people, we are getting qualifications. So we are secondary or primary, you can think yourself. We are secondary then. Knowledge is accumulation body. It keeps on accumulating something. When I started this subject of construction foundation engineering, construction was not a big deal for me in that. Whatever diagrams are there, or we understood that. Our professor used to say, don't worry, just make a sketch. The sketch is clear, give full marks. Even the explanation, don't worry about explanation, just make a sketch, it's enough for me. It means whatever construction you're going to do, a system or apartment construction is, just to understand the sketch means that's your understanding. I say, yes, you know it. And you know that writing students, how they write, we know everybody. Engineering students, their writing is, English skill is not top priority, it's not very good. And we used to go, this is colored English, don't worry about this, colored English class. I mean, not literally literal language, just color language. We mix up this and that and say, okay, fine, it works. But as far as script-based engineering, our opinion, our thoughts are in English, and that's okay. So, drawing, sketch, I can say, we used to say drawing is language of engineers. That's true. Drawing is language of engineers, sketch is language of engineers. Means if you know what sketch you can draw only when you know what you have to do. So it says, yes, you understand, write whatever written, so finally accept that you must. When you understand, you are drawn, you understand. This means, because remember, drawing cannot be crammed. You can cram writings, but drawing formulas can be crammed, but you know, drawing cannot be. You have to, because you can't remember that. They're so complicated. Drawing sometimes means sketches are so complicated, because sections of some drawings are so complicated. You can't remember until you understand that concept. If you understand that concept, then you can draw without even remembering anything. Those concept is clear to you. You can immediately draw and understand what you are doing. Same, no. Analysis of soil is also very important. It's not simply we take samples and do. That's the process of testing and collecting samples. That's the process of one. My question is not process. Question is understanding of that. I talked of soil many times, but soil cannot be explained in 2 hours or 3 hours, because this subject is very, very wide. It's more important than the structure itself. We have, of course, we have some softwares of soil. I don't believe those softwares. I found somewhere that some softwares. Which softwares cannot tell you about soil. I limited yesterday confined to improvement of soil properties. We yesterday can say I was confined to soil improvement. Let's say I was talking about this soil improvement. First we're talking of. And we talked of Indian standard classification, then all this we talked of, and then I jumped on to soil stabilization, that we continued. Soil stabilization, where it was. Let me go to, so far I just explained what we are, we should, and now stability of slopes I will take later. Stability of soil, that's important. Is payment design, soil stabilization. Yes, that's right. It's here. So we confined yesterday on this, and this is our, I can say, how this moving is okay. Yeah, it's going on. It's not here. I'll take some time in this now, and this was yesterday we discussed about the stabilization of soil, and this was regarding soil stabilization, bypass poor soil, remove poor soil, redesign structure, treatment of soil to improve properties, method of soil stabilization, and this method is this mechanical stabilization, cement stabilization, lime stabilization, bitumen stabilization, and membrane stabilization, electrical stabilization, thermal stabilization, chemical stabilization. When we move out to that, and we reach to, somewhere after all these studies, we move to approximate limit of particle size, and we studied other tables, and we reached to one example also we considered, that was stabilization for that, and we worked out in that how to mix up various components, various different materials to reach to some defined or demanded for particle size distribution. Creation, design a trial mix for particle size distribution from gravel, example of gravel, crushed gravel, and sand, and silty sand. These were given there, and crushed stone, crushed stone was 38%, sand was 42%. We have to create something from different materials. How to create that? How to generate that sketch? Considering sieve sizes and percentage passing, and we reached some status where we had some this graph, and on this we had some lines where we produced that with different curves of depending on your available sieve passing parameters. Then we got a result about equivalent area, so that we could find various various percentage passing for final result. And then we went on to, this was only for purpose of designing your backfill or designing earth to reach certain defined parameters, and that was a process, completely technical one. And so maybe you missed that through. I also missed that in education time because nobody understands that time. But in field you have to understand that. I did that, means not through this procedure, but I mixed the various soils, very important local and level soils, and used that for filling purpose. And so that's experience actually. Then we have to do cement stabilization of soil, which is method of mixing, etc. So now in the same stabilization, the traveling plant method, the methods of there's a traveling plant method in that, is also stationary plant method, continuous mixers, batch mixers. Then we have the lime stabilization. Now I'm continuing this. Lime stabilization we have to do, as well as bitumen stabilization we have to understand, membrane stabilization we have to understand, electrical stabilization, chemical stabilizations, and these stabilizations we have to understand. And then we have to see many other natural resins and all that, how this happens. But this is going to be very elementary here. But we have to understand our practical aspect also in this. Now this is because cement stabilization we are talking of. We have to expand that also from practical point. We talk cement stabilization because this was very old record. I searched out many more in that. Now let's move to that one. I'll refer to you to my papers that I'll open some files. Those files are not with them. Just going to going to speak basis on those files. I have to go to basics one, not in this office, sorry. I have to go to my E and find them. I'll talk of that first because that's very important from practical aspect, because you cannot limit yourself to books alone because books are not practical engineers. So sorry, now there are files that these files are, I should say, various files are there. So effects of granulated blast furnace slag, then it's there. Then we can say effects of done to blast furnace slag in engineering behavior, affects control stiffness columns, affects deep soil mixing, affects hydraulically bound material and cement bound granules, and affects lime and cement stabilization contractor. Okay, affects soil modification, fill drying, and affects vibro-stem columns. So I will like to first open this file. This sorry, effects of granulated blast furnace slag. This is also a paper, you can say. Let's open this and see what does it say. Now this is a file here. This is a kind of technical paper. This was written by someone, published by someone, and that is I think this is Elsevier. This is available online at www.sciencedirect.com. This website, www.sciencedirect.com. Cyverse Science Direct. So this is that reference I have, because my duty to tell you reference also. It's not my paper. I'm just going to refer it and explain on that. So this is Elsevier, and this paper is there. Affects this chemical, civil and mechanical engineering track of 3 inches. Therma University International Conference. It was there. This is a chemical, civil and mechanical engineering tracks of 3 inches, Nirma University International Conference, and this is in 2013, 7 years back. Effects of granulated blast furnace slag in engineering behavior of stabilized soft soil. Lakshmikant Yadu and Dr. R.K. Tripathi, Assistant Professor, Civil Engineering Department, NIT Kanpur, GE Road, Raipur, Chhattisgarh, and then Dean, PND, NIT Raipur, GE Road, Raipur, Chhattisgarh. Now it says this paper evaluates potential of granulated blast furnace slag to stabilize a soft soil. Soft soil samples were collected from Tribandi Atari Rural Road of Raipur, Chhattisgarh. The soil was classified as CIMI per Indian Standard Classification System ISCS. Different amounts of GGBS, that is 3, 6, 9, 12% were used to stabilize soft soil. Performance of GBS stabilized soils was evaluated using physical and strength performance tests, namely plasticity index, specific gravity, free swelling index, compaction swelling pressure, California bearing ratio CBR, and unconfined compressive strength UCS. Based on strength performance tests, optimum amount of GBS was determined as 9%. Moreover, results indicate that inclusion of GGBS increases strength of soft soil. For example, UCS of 9%, GGBS modified soil was found approximately 28 degrees higher compared to raw soil. Means 9% GGBS was added, modified the soil, and you got UCS which is 28% higher compared to raw soil. Similarly, significant improvement was observed for unsoaked and soaked CBR value of soils. Soft soils which contain montmorillonite. Soft soils which contain montmorillonite clay mineral show major volume changes due to change in moisture content. These soils create many construction and performance problems. These soils means, say, expensive soils, I can say. These soils we are talking of clay type or clay or black cotton like that. These soils create many construction and performance problems in site due to swelling and shrinkage, conduct or behavior. To prevent these problems, stabilization of these soils is required. Apart from mechanical compaction and soil reinforcement methods, different soil stabilization materials are also available. That is lime, cement, fly ash, blast furnace slag, rice husk, ash, etc. to stabilize and improve strength of soil. Stabilization of expensive soils with cement and lime is well documented. Soil stabilization with cement is not preferable because of increasing cost of environment concerns also related to its production. Production process of cement releases carbon dioxide CO2 in environment approximately 1 ton, though it's little less, 1 ton of carbon dioxide released during production of 1 ton of cement. Production of lime also emits carbon dioxide in substantial amount to environment. Moreover, lime containing sulfates is not suitable for soils. Means limes containing sulfates is not suitable for soils because presence of sulfates may increase swelling due to formation of swelling minerals such as atractite and thaumasite. These facts forced to find alternatives to cement and lime. Now it's important to focus on use of other industrial waste materials like fly ash, rice husk and GGBS. At present, use of various industrial waste products for stabilizing soft soil have attained considerable attention in view of increasing cost of waste disposal and environmental aspects. Blast furnace slag is produced as a byproduct during manufacture of iron. During manufacture of iron in a blast furnace, results from fusion of limestone flux with ash from coke and siliceous and aluminous residue remaining after reduction and separation of iron from ore. Iron blast furnace slag consists essentially of silicates and aluminosilicates of lime and other bases. Various researchers evaluated potential of granulated blast furnace slag GGBS to stabilize soils. Now I'll continue this. Hold on, please. I'm interested to find some meaning here, which is RHA. Google RHA. Waste material. This material is called RHA. Let me see what actually that is. RHA is a rice husk ash. Oh my goodness, why they could not use rice husk ash? Rice husk ash, RHA. Rice husk ash is an abundantly, I'm just giving a reference, please don't take it otherwise. Rice husk ash, RHA, rice husk ash is an abundantly available waste material in all rice producing countries, and it contains about 30 to 50% of organic carbon. In course of a typical milling process, husks are removed from raw grain to reveal whole brown rice, which upon further milling to remove bran layer will yield white rice. Current rice production in the world is estimated to be this much. So this is waste material RHA. This is mesoporous material. Utilization of waste material RHA into a mesoporous material. Lime. So this is rice husk ash. I got this word. I could not find till yesterday. So why I'm concerned with this is because of this, that this scientist studied for that effects of GGBS, ground granulated blast furnace slag on strength of soil. On strength of soil, they found that lime GGBS soil stabilized mixes with and without addition of gypsum or containing partial replacement of GGBS by fly ash produced high UCS and CBR in comparison to soil. They also concluded that partial replacement of GGBS with fly ash further further increased UCS, unconfined strength, UCS, and others Muslim studied that effect of mixing of GGBS on consistency, compaction characteristics, and strength of laterite soil. GGBS content glass granulated glass plus slag content, ground glass content varied from 0 to 15% by dry soil weight. We observe that a decrease in both liquid and plastic limits. These are attribute limits, and increase in plasticity index with increasing GGBS, ground glass furnace slag. Further observe that compaction cohesion and CBR, California bearing ratio, increase with increasing GGBS content up to 10%, and then subsequently decreased. So only limit is 10% there. Angle of internal friction decrease with increase in GGBS percentage. Wong studied effects of GGBS collected from different sources and with different grading on performance of pavement materials, and observed that higher early strengths from fine GGBS, high early strengths from finer GGBS. He also found that GGBS is preferred when longer working time are required, and GGBS can be as effective as Portland cement, in controlling erosion. While another one, engineers studied use of GGBS to highway and other foundation layers by determining beneficial effect in reduction of expansion due to presence of sulfates. Beneficial effect in reduction of expansion due to presence of sulfates. From study, they concluded that small additions of GGBS to sulfate, containing clay which are stabilized with lime, reduce substantially their expansion. Means small addition of GGBS to sulfate containing clays, means clays those contain sulfates which are stabilized with lime, and they are stabilized with lime, and if this, because of GGBS addition, this reduces substantially and expansion when exposed to water and have no significant deleterious effect on strength development. So from study they concluded that small addition of GGBS to sulfate containing clays which are stabilized with lime reduce substantially their expansion when exposed to water and have no significant deleterious effects on strength development. Also observed that there's a decrease in plasticity index, significant increase in strength, and shear increase in maximum dry density, slight increase, They also observed that there is a decrease in plasticity index, significant increase in strength, and slight increase in maximum dry density with a decrease in lime GGBS ratio, decrease in lime GGBS ratio. Another one, Huggins investigated effect of using GGBS and lime on swelling characteristics of kaolinite, and another one, this is Kummeridge clay in site, kaolinite and Kimmeridge clays in a site trial. This trial showed that GGBS was completely successful in reducing swelling caused by sulfate. They also observed that optimum lime GGBS ratio to achieve maximum UCS is 1:5. 1:5 means they observed that optimum lime GGBS ratio to where to achieve maximum UCS is 1:5, means 1 lime 5 GGBS for kaolinite clay, and that optimum is 2:3 for Kimmeridge clay. Higgins and Kennedy also carried out a site trial using GGBS and lime on a temporary diversion to carry a 421 Tingerwick bypass traffic in UK. This site contained sulfate containing boulder clay. They used GGBS activated by lime in particular sections and lime and cement in other sections. Found that temporary diversion performed well over a year. They did not observe any swelling problems in sections which were treated with GGBS. Achieved GGBS activated by lime, while observing indications of expansion of section which was treated with lime and cement without using GGBS. This is a long sentence. I'll repeat this one. Just the water, please. Just some water. Okay. Alright, so let's continue with this. Sorry. So what I said, this site contains sulfates containing boulder clay. They use GGBS activated by lime in particular sections and lime and cement in other sections. So lime activated GGBS and lime activated GGBS and lime and cement in other sections. And later on found that temporary diversion performed well over a year diversion of that road. They did not observe any swelling problems in in sections which were treated with GGBS activated by line while observing indications of expansion at sections which were treated with lime and cement without using GGBS. Niraja and Rao utilize industrial waste like RHA, is a rice husk, just came to know this waste, RHA rice husk, FA, fly ash, and GGBS, ground laminated blast furnace slag, as stabilizing agents for construction of flexible pavements on expensive clay subgrade. They found that there is a maximum change in properties with addition of lime up to 5% RHA and up to 5% RHA and GGBS up to 15% and FA up to 20%. They found that there is a maximum change in properties with addition of lime up to 5% RHA addition of lime up to 5%, RHA and GGBS up to 15%, and FA up to 20%. So lime is there up to 5%, RHA and GGBS up to 15%, and FA up to 20%. And then the Annual Act, that is 1415, investigated potential of RHA and FA to stabilize black cotton soil and determine the optimum content for soil stabilization. Sharma and other one Shivapullara studied improvement of various engineering properties of expensive soil by using waste material GGBS as an alternative to lime or cement, so as to make it capable of taking more loads from foundation structures. Now observe also that strength improvement depends on amount of GGBS used and effect of curing period is less pronounced. Observe that strength improvement depends on amount of GGBS used and other effect of curing period is less pronounced. Further, they have concluded that initial tangent modules values generally increased with increased GGBS content. Now, in context of this explanation, it has been decided to perform similar study on soft soil collected from Tatibandh, Athari Road District, Raipur, India, to know potential of non-grounded granulated blast furnaces like GBS alone as an additive and to evaluate cost-effective mixing proportions. Further, to study effect of GGBS in cost-effective proportion, experimental programs was undertaken and results of these tests is reported in this paper. Now, material and methods, let us say, location of study, materials and method, location of study. Soil sample used for this study was collected from Tatibandh Athari Rural Road District, Raipur, Chhattisgarh, India, at depth of 0.4 meters using method of disturb sampling. GBS was obtained from Bhilai Steel Plant District, Durg, Chhattisgarh, India. Durg, Chhattisgarh, India, Bharat. 2. Testing methods. Laboratory tests carried out on natural raw soil. Laboratories carried out on natural raw soil includes atomic limits, pH value, specific gravity, compaction, free swelling index, swelling pressure, CBR and UCS. Engineering properties of soil were determined in accordance with Bureau of Indian Standard BIS. Specimens for swelling pressure, UCS and CBR tests were prepared or optimum moisture content and maximum dry densities. Swelling pressure, unsoaked and soaked CBR, swelling pressure, unsoaked and soaked CBR and UCS. UCS tests were conducted as specified by Indian Standard Codes IS 2720 Part 4, 1977, IS 2720 Part 16, 1987 and IS 2720 Part 10, 199 respectively, 1991. Compacted specimens were cured for 96 hours for conducting soaked CBR tests. Preparation, properties of soil and GGBS. Soft soil and GGBS properties were evaluated in accordance with BIS in laboratory. Soft soil was identified as inorganic fine. I'm sorry, it's technical word written, but due to ice problem, I'm a little small item. Inorganic fine grained expensive soils with blackish gray in color. Specific gravity and pH value of soft soil. So I missed something now. Just a minute. That's 2 minutes. Soft soil and GGBS properties were evaluated in accordance with BIS standards. Soft soil was identified inorganic fine grained expensive soil with blackish grey in color. Specific gravity and pH value of soft soil was evaluated. Specific pH value of soft soil were evaluated and specific gravity was 2.56 while pH 7.62. Liquid limit, plastic limit and plasticity index of raw soil were found. Liquid limit 16%, plastic limit plus 29% and 17% is plasticity index, because liquid limit minus plasticity means this 46 minus 29, 17%. Engineering properties of soft soil are shown, which you read below. I show you. I'll speak all as referred to Indian Standard and ASHTO soil classification system. Soil was classified as CIMI and A75 with 4% group index GI respectively. This shows that raw soil below standard recommended for most of geotechnical works and would therefore require stabilization, and GGBS was identified as non-plastic NP material and having high specific gravity and pH value as compared to soft soil. These properties are given as follows. This is table 1, properties of soft soil, is given, I speak. Soft soil, inorganic soil, black common soil. So we continue properties of soft soil, table 1. There, table 1, soil characteristics and description. Now in this case of soft soil, is field moisture content 18.5%. Field moisture content 18.5%. Liquid limit 46%. As we saw there last boat, liquid limit 46%. Plastic limit 29%, plasticity index 17%. Maximum dry density 17.6 kilonewton per meter cube. Optimum moisture content 11%. CBR value soaked 1, California varying ratio soaked 1 2.05%, and CBR value unsoaked 8.14%. Free swelling index 83%. Free swelling index. Free swelling index 83%. Swelling pressure 41.8 kilonewton per meter square. Specific gravity 2.56 and pH value 7.62. Indian Standard Soil Classification CIMI. Ashtu classification A75-4. Now table are the 1, 2 properties of GGS. Field moisture content 3.52%. Field moisture content. Maximum dry density 19.8 kilonewton per meter square. Optimum moisture content 9.3%. CBR value soaked 4.1%. CBI value unsoaked 11.14%. Plastic limit, non-plastic NP, and now we move on to another interpretation of this, and that is blended mixed proportions. My chest is sweating. I'm just trying out. So it's uncomfortable. Sorry for coughing. Soil is soil. Cannot avoid this. And those avoid this, they are not engineers. Sorry, what to do? I am I am not having any comfort from my room. Life has to move on. Now, GGBS used in this study was blended with soft soil. GGBS was blended with soft soil and in different proportions, that is 3%, 6%, 9% and 12% by weight of soft soil to obtain optimum amount for stabilization. Physical and strength properties of blended mix was evaluated in laboratory and compared with properties of soft soil to obtain optimum amount of GGBS. Now results and discussion. Just exercising also in between because I have no time for exercise. Achterberg limits. Achterberg, German scientist. Agriculturist. Achterberg limits of blended soil was determined per IS 2720 part 5. 1985 liquid limit, plastic limit and both decreases with increasing percentages of GBS. Right, no problem, relax. Achterberg limits of blended soil was determined for IS 2720 part 5, 1995 liquid limit and plastic limits both decrease with increasing process of CGS, which is similar to observation quoted by Kinnison that plastic index was. So what we say, these limits, Achterberg limits of blended soil was determined per IS code I2720, and liquid limit and plastic limits both decrease when increased percentage of GGBS. Percentage of GGBS increasing, is soft soil increasing, but only limited percentage we can say not all percentage. So when you get GGBS, this plastic limit and liquid limit decrease, which is similar to observation reported by Akimusoro. While et al. Variation of plasticity index with various percentages of GBS is shown in figure. It was inferred that plasticity index decreases with increasing properties of CCBS. Compaction properties. Hold on. Yes, we go further. Says that compaction properties of blended mix. Compaction properties of blended mix. Mix is already blended. So compaction properties of blended mixes were determined in accordance with IS 2720 Part 8 1983, and a variation of MDD and OMC is shown in figure. I'll speak that one. Now from figure 2 and 3, okay, it's confirmed that MDD increases, and OMC decreases. MDD means dry density increases, and OMC of mesh conjugate decreases with increase in percentage of GGBS. What happens? Your dry density increases while maximum dry density increases, and your optimum moisture content decreases. This means at lower quantity of water you can get maximum dry density. In MDD can be attributed to replacement of soil by GGBS in mixture. Okay, then in mixture, which increase in MDD can be attributed to replacement of soil by GGBS and mixtures which have relatively highest higher increase in MDD can be attributed to replacement of soil by GGBS, and in mixture which have relatively higher specific gravity 2.89 compared to that of soil, which is 2.56. So from 2.56 we got to 2.89. Increase in MDD may also be explained by considering GGBS as filler with higher specific gravity in soil voids. There was a decrease in OMC with increased GGBS content addition of GGBS. Decreased quantity of free silt and clay fraction and smaller surface area require less water. Addition of GGBS decreases quantity of free silt and clay fractions. smaller effect surface area required less. Decrease OMC with increase GBS content, addition of GBS, decreased quantity of free silk and try to understand. That's important. Since there was a decrease in OMC when increased GBS content with increases content, addition of GBS decreases quantity of free silt and quantity of free silt and gray fractions, and smaller surface area required less water. This implies less water is required in order to compact soil with GGBS. Let's go further. So addition of GGBS decreases quantity of free silt and clay fractions, decreases quantity of free silt and clay fraction. Hence, smaller surface area required less water. This implies less water is needed in compare compact soil and GGBS connections. Just let me ensure whether just half a minute, please. Excuse me. Okay, sir. I just put some water on my legs also to keep them cold. All right. Sorry for disturbance here. I forgot where I was. Yes, it is. It's I think. So this implies less water is needed in order to compact soil with GGBS mixture. This is now pro. Then swelling behavior. Free swelling index. Swelling behavior. Free swelling index and swelling pressure test were conducted in accordance with IS 272 Part 40, 1977 and IS 2720 Part 41, 1977. on samples prepared at optimum moisture content. Now there are figures the variation of swelling pressure and free swelling index respectively by addition of varying percentage of GGBS, which is similar to observation reported by Higgins et al. 1998-4 and Boyle et al. 1996-11. Blended mix of 9% GBS. GGBS reduces free swelling index and swelling pressure at about 67% and 21% respectively. So reduces free swelling index and swell pressure at 76 and 21% respectively from its unstabilized counterpart. Now, unconfined compressive stress. This is most you can say useful. Unconfined compressive stress. This is most useful and adaptable method of evaluating the strength of stabilized soil and effectiveness of stabilization. Most unconfined compressive strength UCS is most useful and adapted method of evaluating strength of stabilized soil and effectiveness of stabilization. UCS is unconfined compressive strength tests work conducted on soft soil and blended materials in accordance with IS 2720 Part 10 and 1991 in remolded sample at length to diameter ratio. Variation of UCS with increase in GGBS from 0 to 12% is shown in figure, which is similar to observation reported by Nirja and Rao in Wild. Now there was a sharp increase in UCS. And addition of GGBS when compared with UCS value of natural soil. UCS value further increases with addition of GGBS to its maximum at between 6 to 9% GGBS, after which it dropped from 0 to 12% GGBS, from 9 to 12 GGBS. Subsequent increase in UCS is attributed to formation of cementitious compounds between calcium hydroxide CH present in soil and pozzolana present in GGBS. Decrease in UCS values after addition of 9% increase. Addition of 9% GGBS may be a decrease in UCS values after addition of 9% GGBS may be due to excess GGBS introduced to soil and therefore forming weak bonds with soil maybe such GGS may motives to say decrease in UCS value after addition of 9% GGBS may be due to excess GGBS introduced on soil and therefore forming weak bonds between soil and cementitious compounds. California-Bay ratio. Now you know that California-Bay ratio. CBR, this California-Bay ratio. CBR value is widely used in design of base and subbase material for pavement as an indicator of compacted soil strength and bearing capacity. It's one of important tests to evaluate optimum amount of stabilizer for stabilizing soft soil. Soaked and unsoaked both CBR tests were conducted on soft soil blended as well as blended material with various GGBS percentages for evaluating optimum amount of GGBS. Soaked CBR tests were conducted on samples compacted at optimum moisture content and soaked for 96 hours in accordance with IS 2720.16/1987. Variation of soaked and unsoaked CBR value with GBS mixes is shown in figure. Now we'll go there, which shows similar behavior as it was observed at CBS. So, California British are doing in soaked CBR tests were conducted in samples compacted at OMC and soaked for 96 hours in accordance with IS 2720.16/1987. Variation soaked and unsoaked CBR value with GGBS mixes is shown in figure, which shows similar behavior as actuals. It was observed that CBR value increases with addition of GGBS up to a certain point. After that, it starts decreasing. For unsoaked samples, CBR value rises rapidly with addition of 3 to 6% GGBS, and then decreases continuously up to 12% GGBS. Increment CBR can be attributed to gradual formation of cementitious compounds between GBS and GGBS and CH control as is soil. So for unsoaked samples, CBR value rises rapidly with addition of 3 to 6% GGBS and then decreases continuously up to 12% GGBS. Increment in CBR can be attributed to gradual formation of cementitious compounds between two GGBS and GGBS. Increase in CBR can be increase in CBR can be attributed to gradual formation of cementing compounds between GBS and COH containing in soil greatly decrease CBR after 6% GBS and be really one minute please, 1 minute please. Sorry, just stretching. Again, I read this paragraph. CBR value is widely used in the design of base and subbase materials for pavement as an indicator of compacted soil strength and bearing capacity. It is one of important tests to evaluate optimized optimum content of stabilizer for stabilizing soft soils. Soaked and unsoaked, both CBR tests were conducted on soft soil as well as on blended materials with various GBS percentages for evaluating optimum amount of GGBS. Soaked CBR tests were conducted on samples compacted at OMC and soaked for 96 hours in accordance with IS 2720 part 16 1987. Variation of soaked and unsoaked CBR value with GGBS mixes is shown on which shows similar behavior conduct as others. It was observed that CBR value increases with additions of GGBS up to a certain point. After that, it starts decreasing. For unsoaked samples, CBR value rises rapidly with addition of 3 to 6% GGBS and then decreases continuously up to 12% GGBS. Increment in CBR can be attributed to gradual decrease, to gradual formation of cementitious compounds between GGBS and COH contained in soil. Gradual decrease in CBR after 6% GGBS may be due to excess GGBS that was not mobilized in reaction, which consequently occupies spaces within sample and therefore reduces bound in soil GGBS mixes. Trend of soaked CBR was similar to unsoaked CBR. Only trend of soaked CBR was similar to unsoaked CBR. Only that's even after addition of 6% GGBS, CBR kept decreasing and rises to peak at 9% GGBS. It slightly dropped at 12% GGBS. This trend shows that presence of water moisture helps to further formation of cementitious compounds between the soil and my fan is working. Yes, there's no power. Fan is working. I'll alternate with. Let's see this alternator. This inverter will be affected. So let me put this off, please. Lights are even in the morning I'm very good to supply this government. I don't know what sort of government office. What sort of government they are running. Okay. What can you say? These people, they are saying improving development, this is development. I've been in this area since 2008 and about 12 years have gone, but there's no improvement in electric supply, same, and they're charging a lot of bill, no improvement. And the smart city, this is useless smart city. Faridabad is smart city. BJP government and this result, they're doing nothing at all. Sorry, see, they are like soft soil. This government is soft soil, I can say. You have to suppress them. Kill a government. Black cotton. I'm going to say. Well, okay, enjoy. Trend of soaked CBR was similar to unsoaked CBR, only that even after addition of 6% to GGBS, CBR kept increasing and rises to peak at 9% GGBS. It slightly drops at 12% GGBS. This trend shows that presence of water helps to further formation of cementitious compounds between soil's calcium or COH and pozzolana and GGBS. Then optimum amount of GGBS. Now we are testing optimum amount of GGBS, which is also a very important point. Purpose of this paper is just price, relative of price purpose. What's actually we want to know. Work has been going on. Very little means not extensive, not very extensive. Very little work has been done on this, and that from, I think, not from a promotional point of view, from their professional point of view. When you want to upgrade their designation somewhere from associate professor to professor only for that purpose. Or strength, optimum amount of GGBS. Strength properties that CBR and UCS test results have been used in most of previous studies. Okay, and this was talking 2013. Previous studies to decide optimum amount of additive of blended soil. In present, we studies the soft CBR, which simulates actual field conditions, and UCS test results have been used to decide optimum amount of GGBS. It can be inferred from figures. Okay, we have figures here. From that, soaked CBR values increased from 2.05% of unstabilized counterpart to maximum value of 11.05% at 9% GBS. It can be inferred from this figure that soaked CBR value increased from 2.05% of its unstabilized counterpart to maximum value 11.05% at 9% GGBS. Similarly, UCS increase from unstabilized soft soil, that is 116.7 kilonewton per square meter, to 152.7 kilonewton per square meter, and 149. So we can say it's from 116.7 to 152.7, that is soft soil, and UCS increased from this value to that value when we added GGBS 9%, and 149.4 kilonewton per meter square by 6% and 9% addition of GGBS respectively. Right. There's no significant decrease in UCS value from 6% to 9% GBS. Hence, from both CBR and UCS, Okay, there's not significant decrease in OCS while from 6 to 9% GBS. Hence, from both CBR news which is consideration 9% GBS. Considers okay. There's not significant decrease in UCS value from 6 to 9% GBS. Hence, from both CBR and UCS consideration, 9% GBS considers is optimum value in addition for free soft soil. Now, there are some graphs here. X-axis is, you can say graphs. GBS is shown on FC side and other percentage index on y-axis ordinates. Okay, now graphics. It's very important point, the graphics. Let's see what it says. Now this is a graph in figure. This is percentage of GGBS everywhere on abscissa and ordinate is what is percentage of that property. In one property it is plastic index. In other property it is MDD. In third property it is OMC. And one is swelling pressure. These are 4 graphs I have here. Also 2 more. One is having same as the free swelling index, and it is UCS, and then it is CBR. So 1, 2, 3, 4, 7 graphs are here. We have to understand this very well. If I can say, I don't know if I'll be able to do that. Let us see if I can show you with this graph by taking photographs. I don't know. I have that. Let me put out this. Okay, let me take this. Okay, this is one. This other. And this another. And this another. Okay, I cannot see 3, I'll take at a time. So I am taking 3 now, I'm showing you these 3. The second I'll take another 3. So let me show you these 3 first of all. Let me show you these 3. This is number 1, and this is, you can see it's the graph here. Yes. So graph, I'll explain this one. Other one is this. And third one is this. And then I'll remove them. Then the one is here. I'll take other one. Other, this 2, 3. I'll take this one here. I'll take this one here. I'll take another one. One more. I'll take this. I'll try to take this as well. This way. It's not allowing. So let me do this 3 first. This 3 I'll show you. And this is this one. Let us see. 4th one. So 4th one here. It's not very clear because they are not very. And then this other one. And then this other one. And I'll take other one more. That is, I'll take that one. This other one, I think last one. So CBR relative, therefore it's this one here. So we'll move further now. I don't know, let it move. remove further here from, keep it here, no problem. I see. 2 hours 35 minutes, no problem. Let me have some sweating on my body. See, 95% humidity, 92% humidity. What to do? How can work? This early morning see what happen on sun. How we can stand that sun? Cannot. How this evaporated? Water is evaporated in that sun's body. So let us just I don't know what to do. I will go to this optimum amounts of GPS. This is conclusion they are saying. What they are saying is strength properties of CBR and UCS. Test results have been used in most of previous studies now, and to decide optimum amount of additive of blended soil and present study soaked CBR, which simulates actual field conditions, and UCS test results have been used to decide optimum amount of GGBS. It can be inferred from these figures that soaked CBR value, soaked CBR increases from 2.05% of UC unstabilized counterpart of to maximum value of 11% at 9% GGBS. Similarly, UCS increases from unstabilized soft soil 116.7 kilonewton per square meter to 152.7 kilonewton per square meter and 149.4 kilonewton per square by 6% and 9% additions of CGBS respectively. There is no significant decrease in UCS value from G6 to 9%. Hence, from both CBR and UCS considerations, 9% GGBS considered as considered as optimum value as additive for soft soil. Hence 9% GGBS they are saying optimum. Now first figure is, this is between GGBS percentage and all GGBS on abscissa and ordinate is air plasticity index. It says at 0% plasticity index is 17. At 0%, this graph says at 0% GGBS plasticity index is 17%, and then if you go to at 3% GGBS it is 16%, that is plasticity index, and at 6% GGBS this is 15% approximately, and at 9% it is 14% GGBS plasticity index, and at 12 this is 13% plasticity index. So reduction in plasticity index comes from 17 to 13, 17 at 0 GGBS and 0% GGBS, and it goes down to 12 GGBS. At 12 GGBS it is around 13. this is achievement in GGBS. At 9 it is, at 9 it's 14, and at 12 it is 13. Then our graph, other graph is that is again, this is MDD, kilonewtons per cubic meter, dry density, maximum dry density, and it says at 0% GGBS this is 17.25 kilonewton per cubic meter. At 3% it is 17.35. At 6% it is 17.55. At 9% it is about 17.7. Let me add something. And then if you go to 6%, it is the 7.55, and yes, at 9 it is around 7.75, and at 12 it's around 7.85 kilonewton per cubic meter. Then you go further to next one, and that is optimum moisture content. I had my skull is wet. The skull is wet. Okay, now GGBS percentage is 0 in this, and 11 is OMC, 11% of the moisture content, and GGBS is 0. So without GGBS it is 11% moisture content, optimum moisture content, and when it is 10.6 or 10.7, this is GGBS is 1 or 3%, GGBS 3%, your optimum moisture content is 10.7%. And GGBS is 6, it is 10.5%, and GGBS is 9%, it's 10.1%, and when it is GGBS is 12%, your moisture content is about 9.9%. So 9.9% here is at GGBS 12. Now it is swelling pressure kilonewton per square meter. I'll take some water. What to do? No other way out. Have to take something to keep yourself. No problem. Right. क्या करूँ मैं इनको? क्या करे इस गवर्नमेंट का, इस डिपार्टमेंट का? खाने पीने वाले हैं सब लोग हैं. पुलिस भी ऐसी है, सरकारी भी ऐसी, सब ऐसी है. कोई चिंता नहीं किसी को. बर्बाद हो जाए देश. Okay, gentlemen, we'll move further. Why to hold on, even if it's some hot or problem after all. So we go to now it's OMEPS. Now we into swelling pressure, kilonewton per square meter, and it is 0%. It is it is 43 somewhere, 43 kilonewton per square meter approximately, and if it is 3%, it is 3%. That gives something about 38 hours, 37 something. Then at 6% of GBS, it's above 35, and at 9 it's in between 30 and 35, say 33 or 34 kilonewton per square meter. This is according to graph. I'm not reading any figure. And then you go to this is free swelling index. That was GGBS, swelling pressure of GGBS mixes, and this, and now it's free. Without free, it is GGBS percentage is free swelling index is GGBS is 0. It is about 83 and 83%. At 3 GGBS 3%, GGBS about 52 or 53. Then at 6 GGBS percent is about 35, and at 9 is about 30, like that. Then UCS, kilonewton per square meter, it's GGBS percentage 0. Then UCS is 116. Then go to 116 kilonewton per square meter. Take at GGBS percentage 3, and this is about 140 kilonewton per square meter UCS, and this is at 6 it's about 150 kilonewton per square meter, and 9 is about 145. 9 12 is about 146 and 47 probably, 7 12. And then we go to CBR percentage, which is last graph, I think, and this is at 0. At 0, there are both values in the soaked and unsoaked. And first, I am going to tell you about this is soaked, and this is about at 0 GGBS, 0% GGBS, it's 8, and at 0 GGBS 3% is 11, and GGBS 6% it's about 20, and GGBS at 9% it's about in 18 or 19 thing, and it's about 12 GGBS is about 18. This is for soaked one, and for unsoaked this difference complete down. So at GGBS 0, it has come from 8 to soaked. It's come down from 8 soaked to unsoaked, and at 3% GGBS, it's come down from 14 soaked to about 14 soaked to about 3 or less at 3 GGBS, and at 6 GGBS, 6% GGBS, it has come down from 20 to say 8 or less, 7.5, and at 9% GGBS, CBR was at 18, is now at about 10 or 11. Then so it is at 12, it's 18 to 9 is at 18 to, this has come down to 11 something, at 12 it's come down to 18 to 9. So what is conclusion here? That's a conclusion paragraph. These authors have written. Said study has been conducted to assess potential of GGBS to stabilize soft soil. For study was identified as CIMI per Bureau of the Standard Survey classification system. Soft soil was mixed with various percentages of GGBS, that is 3 to 6 to 9 and 12. Physical and strength properties have been evaluated experimentally on raw and blended soil. Results indicate that use of GGBS significantly improves physical and strength properties of soil. MDD increased while OMC decreased. Soft soil was mixed with various percentages of GGBS 3, 6, 9 and 12. Physical and strength properties have been evaluated experimentally on raw and blended soil. Results indicate that use of GGBS significantly improves physical and strength properties of soil. MDD increased values whilst MDD increased while OMC decreased with addition of GGBS to soft soil. Now, next line is result indicate that use of GGBS significantly improves physical and strength properties of soil. MDD increased while OMC decreased with addition of GGBS in soft soil. There is a significant reduction in swelling behavior of soil based on strength results. Strength test optimum amount of GGBS was determined as 9%. Soaked CBR and CBR and UCS value increased about 100% and 28% respectively. Source CBR and UCS, okay, by addition of optimum combination of GGBS. Moreover, blended mix of 9% GGBS so 9% is that point, we can say. Then soaked CBR and CS value increased about 420% and 28 respectively by addition of optimum amount of CBG and more blend mix of 9% GBS reduces free swelling index and swelling pressure drop 60% 21% now. Now this paper has gone, so what we have studied in this paper, this means RHA, and okay, now we'll go to something else. It's about paper was technical paper. It's very important area. We'll going to know about experimental results conducted by those scientists or engineers in 2013. Now let's go to something else, and that's where we are going. We'll go to next paper. not paper. It's the facts of ground. It's okay, same. It's the same in fact. This is same, so we'll go to effects of control stiffness columns, deep soil mixing, hydraulic bound material, lime and cement stabilization contract, soil modification, filtering. Okay, why with soil modification? Let us see. What is soil modification? That we can see soil modification. What is soil? We want to understand by soil modification. Let us see. Soil modification. Soil modification is process of creating a controlled filtering method which makes sure that soil is at correct moisture content to achieve maximum compaction. We have certain papers here, and that is soil modification filtering, and there's another one, and that is affect this control stiffness column and ground and then deep soil mixing and hydraulically bound material, then lime and cement stabilization, and then soil modification, then and vibration columns. So let's say about soil modification filtering. Soil modification filtering ground development. What is that? We have to understand this. Why I don't respond? It's a problem with the log, It doesn't respond many times. Oh, come on, yeah, don't waste my time. So this is responding soil modification filtering. What is it? Now it says soil modification is process of creating a controlled filtering method which makes sure that soil is at correct moisture content to achieve maximum compaction. Structural earthwork has been carried out successfully in the United Kingdom for many years. However, to maximize and value or realize land investments, many sites are reprofiling to meet requirement design levels or all necessary developments. This is from now. Many sites are profiling to meet required design levels for allow new development. So now it makes some sense to make use of site fill materials, fill materials, and place them in a controlled manner which avoids foundation loadings, back down, fill material. What it says, let's go that one. This is UK climate and its soil conditions, and given there is no accurate method of controlling one soil's moisture content, face a real challenge to meeting requirements of high performance density driven specification, especially when an industry requires standards as minimum 95% compaction, less than 5 air points. Air voids per 5% right, for maximum high-end performance situations such as under building foundations. We are successfully using soil modification techniques as an effective means of gaining control of soil moisture content during course of undertaking structural earthwork operations. This fill dry technique have been proven to achieve required density driven specification, and it has met requirement of engineers, clients and insurers on various projects throughout United Kingdom. Advantage of soil modification. Its conditions. Advantage of soil modification is its conditions non-engineered materials to an appropriate engineered solution. Says non-engineered it conditions non-engineered material to an appropriate engineered solution. High strength fill material with minimum settlement of soil. Engineered backfill ready for pad or stiff foundation. Engineered backfill for ready for pad or stiff foundations and ground bearing floor slab. Why my time you are wasting? You are my enemies, I think. How can humidity is a problem, temperature is not a problem. This water, moisture sticks to skin and pinches, High strength fill material with minimum settlement or soil. So, engineered backfill ready for pad, stiff foundation and ground bearing floor slab. It reduces the need for deep foundation works, imported soil stone, mass concrete and piling. No requirement for stone capping, layers on roads, car parking areas. Creates a capability to recycle on site materials. Creates a capacity to recycle on site material, thereby reducing material going off site and decreasing aggregate come back to soil. I'm going out. So capacity creates the capacity to recycle on-site materials, thereby reducing material going off site and decreasing aggregates coming back on site, and reduces environmental impact through better use of existing site materials and reduce haulage. Now applications. What is application? Virtually worthwhile project. There's desire to maximize reuse of site, one soils and minimize cost of foundation solution for both buildings and roads. GDL was placed to provide contractors with specifiers with practical technical advice. Now this is organization for this. So let's go for this. Now it says soil modification process. Some pages something is missing there, so no problem. And this is groundwater development scope.uk. This is URL of this. This is ground development.co.uk. Ground improvements of soil stabilization, soil modification thing. So excavate and replace with engineered material in same performance requirement as subsequent move. Soils intended for modification may be treated either in situ or in cut area prior to excavation and depositing. To do struggles for nothing, no achievement in this struggle, just waste of time. This morning what's happening, every half an hour they drop light. That's the reason I do in morning, but it's no use. Morning also wasting time. Okay, no problem. There are merit soils intended for modification may be treated either in situ, in cut area prior to excavation and deposition as fill elsewhere on site, or alternatively in situ once placed in a control layer thickness in fill situation. There are merits to each proposal, to each approach, and this would determine on a project specific basis. However, it's critical that adequate grading takes place in ready material for stabilization, because we must make sure that materials are treated in controlled layer thickness. This allows us to check that all materials are treated to required degree without thin laminations. Thin laminations of untreated materials between layers. I will read again this paragraph. Soil intended for modification may be treated either in site or in situ on cut area prior to excavation and deposition as fill elsewhere on site, or alternatively in situ once placed in a control layer thickness in fill situation. There are merits to each approach, and this would be determined on project specific basis. However, it's critical that adequate grading affects to ready materials for stabilization, because we must make sure that materials are treated in a control layer thickness, and this allows us to check that all materials are treated to required degree without the lamentations of untreated materials between layers. Now this required dose of proprietary dry binder. Proprietary dry binder is then spread over materials which are undergoing treatment using a computer controlled binder spreader. We operate fleet of modern this company is taking. They operate fleet of modern self-propelled spreaders which offer a higher degree of accuracy and minimize production of whatever airborne dust during process. Type and quantity of binder that is required for each project is determined through an initial design testing that is normally carried out prior to site start and then on an ongoing basis to allow for variation in ground. Most commonly used binders are hydrated quicklime and cements, but others such as pulverized fly ash and GGBS may be used developing on requirements of each project. Well, so once again I read this require those proprietary binders and spreader materials which are undergoing treatment use a computer controlled binder spreader. We operate this company says operate a fleet of modern self-propelled spreaders which offer a high degree of accuracy and minimize production of high degree of which gives self-propelled spreaders which offer high degree of accuracy and minimize production of any our airborne dust during process. A type and quantity of binder and that is required for each project is determined through an initial design testing that's normally carried out prior to site commencement, site start, and then on an ongoing basis for and ongoing basis allow for variation. The type and quantity of binder that's required for each project is determined when initial design testing and is normally carried out prior to site start and then on ongoing basis to allow for variations in ground. Most commonly used binders are hydrated limestone, hydrated quicklime and cements, but others such as pulverized fly ash, PFA and ground granulated blast furnaces like GGBS may also be used depending on current. Now, most commonly used binders are hydrated quicklime and cements, but others such as pulverized fly ash and GGBS may also be used depending on requirements for each project. Mixing effects to incorporate binder. Mixing effects to incorporate binder into soil. Binder GGBS or soil. Our preference is to utilize one of very high efficient vertigen self-propelled stabilizing machine, although our fleet also include tractor mounted variants for use on small sites and in lighter soil conditions to ensure that we can deliver exactly what our client use. on a client, in certain circumstances such as when working in heavy clay type soils, secondary mixing may also be required to achieve correct degree of pulverizing. दे दो यार, लाइट क्यों मार रहे हो? In certain circumstances, as when working in heavy clay type soil, secondary mixing may also be required to achieve correct degree of pulverization. In these cases, metals are graded to ensure correctly a thickness is maintained, compaction, and then compacted with specified number of passes. A heavy soil compaction process is repeated to stabilize layers. तो करेंगे ऐसे what to do, no way out, क्या रास्ता है? Throughout process of doses and excitators utilize GPS technology to ensure that we accurately control layer thickness and ensure that no area of fill is overcut or off-filled. Testing is carried out during works in accordance with specified requirements, which can includes density testing and strength testing by means of severe plate load test. So this is the paper. Close this now. I think I should do this. This is gun development PDF. Now control stiffness columns. Let us see. Control stiffness columns. वही करते हैं, कुछ और भी करेंगे. अब क्या करें? This is ground stoppers column. Let us see how can we show them how it works. Let's do it. So also put on by. So in this, I'll show you this figure first, so that you understand that. This is that. This is the graph of this ground stiffness column. So this is that sketch. Important one, this column. I'll talk of this, about this, and that is important one here. It says that control stiffness column. This is called control stiffness column. So again, I'll show you again this one. Control stiffness column. Okay. Control stiffness columns. Control stiffness columns rigid inclusion. This is ridged inclusion in conjunction with transfer slab to improve soil characters of soft formation soil and reduce imposed Alright, now we'll go further. Let me keep it here so it will not fall, otherwise it can fall. I introduce control steps columns in conjunction with the transfer slab to improve soil characteristics of soft formation soil and reduce impose settlements of loads exerted by fall of structures. Now these columns are performed without soil removal using a specially designed drilling tool that displaces soil laterally towards borewall. Increase, say, now weak concrete is pumped through. Weak concrete is pumped through. Weak concrete is pumped through internal hollow pipe. A designed load transfer platform consisting of either stabilized soils or imported aggregate with geogirder is placed over columns. This effectively transfers imposed loading from upfill or structure onto improved. A designated load transfer platform consists of either stabilized soils or imported aggregate with geogrids is placed over columns. This effectively transfers imposed loadings from upfill or structure onto improved formation soils and displacement columns. This increases, says this increases this weak concrete is pumped through so this is the stiffness columns is called stiffness column. As I said before, we just went, oh my god, this is also funny. What time लाइट बंद करके बैठ गए, क्या करें बहुत सही रहते तो बैठ गए, क्या करें कोई काम. So stiffness columns are performed without soil removal. Means we don't have to remove soil from there. We have to insert this column by itself using a specially designed drilling tool that displaces soil laterally towards bore walls. This increases weak concrete. This increases strength, and weak concrete is pumped throughout internal hollow pipe. Designed load transfer platform consists of either stabilized soils or imported aggregates with geogrids placed over column. This effectively transfers imposed loadings from uplift or structure onto improved formation soils and displacement columns. And this again I show you the sketch, not a sketch but a snap. This is, oh no, don't go away, don't go back here, start here, you are required here. Start, stiffness column, which is used to improve bearing capacity without removing any earth, without removing any part of earth. This is that column. Alright, now I'll remove this. Let's go to other talk, same talk, but here, let's see now. Slavs, good morning, Slavs. Thank you for joining. Continuing with this. It's now. So what we have done? Advantages when compared with our other deep ground improvement techniques. Very cost effective in certain soil conditions. No shock and vibration during column installation. Easy to validate column integrity. High daily production rate. Technical data: columns diameter 250 to 750 mm. 250 is about 10 inches. 250 to 750 mm. Columns depth up to 20 meters depending on soil diameter and consistency. You imagine if you go down to 20 meters down on this case, in this case you drill 20 meters with the machine and filling concrete or slabs. You strengthen this diameter column, this diameter 250, 750, like kind of wild. I know you then strengthen this existing soil. You augment its bearing capacity or its strength using such stiffness columns. Means you are stiffening existing weak soil, soft soil into a stronger one. That's what this. And column depth up to 20 meter depending on soil diameter and consistency. 20 meter depth is stiffened, soil is stiffened. That's the achievement of this according to this method statement. Applications are displacement columns can be used. This is called displacement columns. So stiffness column can be used to improve soil characteristics of soft formation and soil formations. Good lightness component. And it says displacement columns can be used to improve soil characteristics of soft formation soils and reduce in post settlements under roads. Now you can say road and railway embankments, building and house foundations, storage tanks, slurry cut-off walls, hard standings, bridge abutments, retaining walls. Again, you can say roads and railway embankments, means this is good enough for 20 meters down to paying. And building and houses foundations also you can do 20 meter down. Stiffened soil can give you support for a good foundation. Storage tanks, and you can say storage tanks with reservoirs which is maybe underground, below ground or above ground. Slurry cut-off walls, hard standings, bridge abutments and retaining walls, and many more. So this is, again I'm saying, this is from grounddevelopments.co.uk. 7, I'll go to other file, ground resources. Now I'll go to other one, and that file may be deep soil mixing. Let us say deep soil mixing. I start here is maybe, let us see what it says. It's also very advanced technique. This is deep soil mixing, ground improvement. Deep soil mixing, ground improvement. It says, what is deep soil mixing? Deep soil mixing, DSM, is a versatile ground improvement technique and that takes effects in situ which can be used to improve engineering properties of marshland and brownfield sites which comprise of soils including peat which are considered to be soft or very soft with depths of to 25 meters. Deep soil mixing, DSM, versatile ground improvement technique affects in situ, which can be used to improve engineering properties of marginal and brownfield means existing projects, not greenfield sites which comprise soils including peat which are considered to be soft or very soft to depths of up to 25 meters. Now, ground improvement technologies are also used extensively within civil engineering and building industries to engender high strength, low compressibility or improvements of other engineering properties into native soils for purposes of accommodating greater load. Ground improvement technologies are also used extensively within civil engineering and building industries to engender higher strength, low compressibility or improvement of other engineering properties into native soils for purposes of accommodating greater loads. Wet mixing involves introduction of fluid grout with simultaneous disaggregation of soil. With a rotating mixing tool, wet mixing involves introduction of fluid grout with simultaneous disaggregation of soil with rotating mixing tool. Dry soil mixing is used for very wet and or organic materials which have a moisture content high enough that when dry cement binder is applied under pressure and agitated by mixing tool creates a fully fluidized soil cement mixture. In extensive and deep deposits of soft ground, deep soil mixing technology, which traditionally encompasses mechanical agitation of ground with addition of a cementitious binder, is commonplace as a ground improvement method. Chemical process of binder introduction, for example, hydration and subsequent production of primary and secondary cementitious byproducts, ion exchange and flocculation, pozzolanic reaction and carbonation are well understood with very well defined relationship between volume of binder introduced and strength and or stiffness increase for a given binder type of blend. However, mechanics of mixing processes aren't well understood, but that's why our expertise and understanding in this area is vast. We have now they say adaptive technique and equipment that's required which suit range of soil conditions that commonly encountered in the United Kingdom. Okay. I'll repeat this is a little technical base, lots of this again. Wet mixing involves introduction of introduction of a fluid grout with simultaneous disaggregation of soil with rotating mixing tool. Dry soil mixing is used. Dry soil mixing is used for very wet and or organic materials which have a moisture content high enough that when dry cement binder is applied under pressure and agitated by mixing tool creates a fully fluidized soil cement mixture. In extensive and deep deposits of soft ground, deep soil mixing technology, which traditionally encompasses mechanical agitation of ground with addition of cementitious binder, is commonplace as a ground improvement method. Chemical process of binder introduction, for example hydration and subsequent production of primary and secondary cementitious byproducts, ion exchange and flocculation, pozzolanic reaction and carbonation are well understood with well-defined relationships between volume of binder introduced and strength and ore stiffness increases for a given binder type of blend. However, mechanics of mixing processes aren't well understood, but this is where this area is vast, where understanding is vast. We have an adopted technique and equipment that's required to better suit range of soil conditions that we will commonly encounter in our kingdom. What's deep soil mixing process? Let's start with that. Our processes involved are mechanically mixing a wet cementitious grout. Mechanically mixing a wet cementitious grout with soil to produce either soil cement column or a mass block of improved material. The result is a massive increase in compressive and shear strength within improved materials. In this case, soil mixed columns, we can design and provide a composite ground improvement solution which offers enhanced stiffness characteristics, allow a DSM column and surrounding soils to share impose loadings and settle uniformly. High pressure wet soil mixing system has a wider range of working parameters when compared with dry soil mixing. So allowing DSM is deep soil mixing column. One of the benefits of deep soil mixing DSM is this is ground improvement can support advancing equipment and structures. In situ method provides the requirement of significant deep excavations and are associated HRs. This means strength is increased without removing soil, and ground improvement can support advancing equipment and the structure within. There is no need of excavation, and there is no need of excavation to improve soil. This means you can save hazards. So this is what we intend to say, and this is from grounddevelopments.co.uk, and it's utilized for a wide range of projects from smallest up to multi-million pounds scales. Now, technical increases allowable bearing pressure, controls settlement, and reduces soil permeability. So what are benefits are? Technical benefits, engineering benefits: increases allowable bearing pressure, means bearing capacity, controls settlement, and reduces soil permeability. This means permeability is reduced, means voids are reduced. Very simple. Voids are reduced means permeability is reduced. Settlement is reduced means strength compact, soil is more compact. Or you can say a kind already if it is consolidated, though it may not be, but it's compacted as well to some extent and allow bearing pressure. This is one of the benefits of deep soil mixing are roads and railways amendments, building and house foundations, storage tanks, slurry cut walls, cut-off walls and harsh landings, bridge compartments and retaining wall. As usual before it was same here, and here is machine. I think I'll show you this machine, but there are many sketches. Let us see some of this. Let me show you some photo of this. And let me show some photo of this machine back here in this case. There's a photo to say application, and I'm showing a photo actually. Where's that one? Oh, I'm confused. What's wrong with my photo? Yeah, I'll remove this photo first because this has to go. I'll take photograph of this now directly and show you why it's hard actually. I'll show you this photograph here. I'll take another photograph of this machine. One more here and see how can we show. Yeah, it's better. I think it's better. I'll take one more later on. Let me take one more. Let me show you how it works. So I can't take more than 3. I don't have space. I'll show you first these 3. I'll delete them and take another one. So start, I'll take this one. I'll show you this first of all. Let me go here. Alright, now dear friends, this is now here. This is one machine, one post here. You can see. That's correct. Yes, okay, it's like that. Yes, it's like that. Okay. Now I'll take another photo and one to show you that one. Next one, I'll show you next. So let me look next one. I'll show you next one is that. There's this one, okay. Yeah. I'll show you next one. Crawler mounted. This is trailing one. I'll delete one of them and see what can I do. Let me delete one here. one more. I'll show you that one. Yes, I'll take this one with you. So let me go there back. I'll show you this again. So this is that. This is the machine. So I can say take now. Let me see what happens now. We go further and see what it says. That I think this file is over. Let me close this file. So we have gone through this file and we have seen that this is a process of title is by this company is this deep soil mixing, GDL, the deep soil mixing, ground improvement, ground development, etc. And this is that. So deep soil mixing we have gone through. Now I like to go through other one, and this is hydraulically bound materials. One is there, HBM and cement bound granular materials, and then lime and cement stabilization, then soil modification, fill drawing, and vibro stone columns. I'll go through hydraulically bound material first, depending on how much we can talk today. I can because time. Let me see time also. How much time is left? It's 3 hours 47. So I can't show you all today. Let us see about half an hour more. So let me see how much we can go through. But I open this. Let me open this. Deep soil material, hydraulically bound materials is here. Hydraulically bound materials, and it's of course it's good one. Hydraulically bound material, HBM and cement bound granular material, CBGM. Hydraulically bound materials, HBM including cement bound granular material, can be used as a structural layer in design of any high performance pavement. These materials, which consist of aggregate and cement, are both more cost effective and sustainable when compared against asphalt and concrete. Process does not require using aggregate, and frequently we opt for recycled materials. No new materials are required, such as crushed concrete or materials redundant sub-base and road planning. So it means whatever sort of materials can be used, not necessary to bring good new material. And it says suitable aggregates to be incorporated into materials. Suitable aggregate to be incorporated into materials are grading to required profile. In case of recycling redundant sub-bases, surface shall be loosened using dozer mounted time ripper. All machinery is GPS controlled to ensure required grades are attained. Required grades are attained. Area is then proof rolled. And soft compressible formation materials whatsoever that are identified, soft compressible formation materials that are identified are over-excavated and replaced with granular material. Surface is then dampened down by a tractor-drawn browser. Required predetermined addition of cement binder is then spread. Required predetermined addition of cement binder is then spread over surface treatment area using a computer-controlled binder spreader. Mixing takes or mixing effects takes place. I don't use this word. Mixing effects to incorporate binder into material, and during this process a controlled addition of water is added. On completion of mixing, materials are immediately regraded to required profile and then compacted using a twin drum compactor. Testing is then performed to confirm that specified project requirements have been met. On mixing effects to incorporate binder into material, and during this process a controlled addition of water is done. On completion of mixing, materials are immediately regraded to required profile and then compacted using a twin drum compactor. Testing is then performed to confirm that specified project requirements have been met. Water advantages of HBM CBGM: reduction in imported aggregates, recycling of existing aggregates, high strength structural layer in pavement design, can accept traffic without wearing surface in lower traffic areas, can accommodate very high axle and wheel loading, can cost saving when compared against alternatives, most sustainable. And areas of application: container yards, airfields, ports, waste pits, roads and railways, haul roads. And that's what is this file. And this file is, as I said, back to top. Let's go. This file is this is hydraulically bound material HBM and cement bound granular material CBGM, and we can just show a photograph of this if think so better for record, and I'll show the photograph. I delete previous photographs and take this photograph, one photograph only for this purpose, and I think I'll take that one. So let me go and see how it can be done. So it's there. Right, take one more photograph for you guys to show this just for reference. It's here now. It's here. So this is photograph here. I'll show you here. Let's go on again. I'll go down. There's all. Sorry. It's this way. Yes, it's this way. This is important actually. This is the truck. This is unimportant. You can see that where water is going. Surface field. Again the light is gone. They have decided to send light, I think, every half an hour. This is pretty else. Smart city, I'm sitting in nonsense. Development of nation. This is development of nation. Put out light every time. Hell with this government. Really. What to do with this nonsense? Every just 15 to 20 minutes back light was then take a bit drum again. Development. They will develop. Idiots are in this country. Okay, no use of abusing these people. Illiterate people are there in power. Hydraulic requirement is gone now. Lime and cement stabilization contract or something. Let us see what does it mean first of all. How much time I have? 3:55:44. Okay, no problem. Let me complete this. This is now lime and cement stabilization. Lime and cement stabilization, and this is what it says, lime and cement stabilization. Well, I want to take FIDIC also today, but I think it's not possible again today. That lime and cement stabilization can be used to enhance the strength and stiffness characteristics of soils. This form of stabilization is recognized in Series 600 of the specification of highway works series as a matter of providing capping replacement layers. What is that? Capping replacement layers. Technique can be used to provide a cost-effective alternative to imported stone capping layers under road pavements and hard standings. Design strength can be varied to meet specified project requirements. However, CBI values in excess of 15% are commonly achievable. I repeat, lime and cement stabilization can be used to utilize to enhance the strength and stiffness characters of soil. This form of stabilization is recognized in Series 600 of specifications for highway works. Series is a method of providing capping replacement layers. Technique can be used to provide cost-effective alternative to imported stone capping layers under road pavements and hard standings. Design strength can be varied to meet specified project requirements. However, California brings CBR values in excess of 15% are commonly achievable. And then now, utilizing site-worn soils. Utilizing site-worn soils in this manner will nearly always reduce total requirements for imported aggregates and disposal of surplus materials off-site. Benefits not only include cost savings, but they also enhance projects' environmental credentials and provide improved safety standards throughout direction of heavy vehicle movement and processes. Prior to stabilization, formation is initially prepared. Prior to stabilization, formation is initially prepared for grading using GPS machine control dozer that allows us to achieve required grades and cross falls. Required dose of lime or cement binder is then spread over materials that are undergoing treatment using a computer controlled binder spreader. Type and quantity of binder that is required for each project is determined through initial design testing that is undertaken prior to site start and then on an ongoing basis to allow for variations in ground. Mixing takes place to incorporate binder. Mixing then takes place to incorporate binder into soil. Our Vertigen self-propelled stabilizing machine, Vertigen, WRITGEN, Vertigen self-propelled stabilizing machines can mix to a depth of up to 500 mm in single pass. Materials are graded to ensure correct layer thickness is maintained for compaction and then compacted with a specified number of passes with a heavy soil compactor. Now, whatever soft spots identified during compaction are over-excavated and replaced with engineered material to same performance as stabilized materials. Surface is then finally trimmed and last compaction effects. Testing is carried out to confirm that specified project requirements have been met. Let us see again because it's important to know procedure I may miss something, so that I can again and check it without any problem. Because now it says soil stabilized piling methods can offer an alternative to importing of aggregates and often etc. etc. Utilizing site-one soils in this manner shall nearly always reduce total requirement for imported aggregate and disposal of surplus materials off-site. Benefits not only do include cost saving but also enhance projects' environmental credentials and provide improved safety standards through reduction of heavy vehicle movement. Processes prior to stabilization of formation. Prior to stabilization of proposed area, formation is initially prepared for grading using GPS machine control dozer that allows us to achieve required grades and close files. Required dose of lime or cement binder is then spread over materials that undergo treatment using a computer controlled binder spreader. Type and quantity of binder that's required for each project is determined through initial design tests that's undertaken prior to site start and then on an ongoing basis to allow for variations in ground. Mixing and effects placed to incorporate binder into soil. Virgin self-propelled stabilizing machines can mix to a depth of 500 mm in a single pass. Materials are graded to ensure correct layer thickness is maintained for compaction and then compacted with a specified number of passes with a heavy soil compactor. And any whatever soft spots identified during compaction are over excavated and replaced with engineered materials to same performance as stabilized material. Surface is then finally trimmed and last compaction effects. Testing is carried out to confirm that specified project requirements have been met. Now, advantage is reduction in imported aggregates. Now, reduction in imported aggregates, thinner construction makeup using imported aggregates, reduce excavation volumes over cut portion of site. Thinner construction makes volume of reduced disposal volume of surplus excavated soil offsite. Okay, then we go to applications. Capping replacement layers. C greater than CBR 15%. Capping replacement layers. Now, greater than CBR 15%, hard standings and yards, piling matrices, temporary haul roads and compounds, working platforms, crane pads and heavy traffic areas, slope stabilization, and this was filed again from same source, ground developments, etc. So in this I don't find any big diagram except this one, which is here. Just for your information, I take a photograph of this and show it to you, and again I take one snap and delete other one just for record purposes. It should go into video for us view. It's the better, So let's take like this one. Okay. Show this one here. This is photo of this machine. Like this. I know for this one here. It might work. Wow, it might take a while. No, something is wrong. I think. This. Not clear, I think. Whatever it is, this compound, it's like that. Oh, it's material there. God, this material is there. You can see this material there. What is going on there? Oh, this is okay. So this is that. I'll go to say 720. No, this file is off. Let me close this file and then soil modification, filtering and stone columns. Stone columns. I can't say immediately. I'll take that. Let me see what is that. Soil modification, filtering, soil modification, filtering, and you say soil modification, filtering. This says I take this as I don't think it's very long. No, it's not very long. Can be taken up. This is soil modification, filtering. Let me take one photograph of this matter before going further, so that I'll take this photograph for this case and show you. So let me take this photograph first. I'll share this photograph. This is this machine. This is trade-off machine, one partition. This machine is used for this purpose. I put in beginning so that I take it off now. So let's sweep this here. Now we move further to study this. It says soil modification, filtering. Soil modification is process of creating a controlled filtering method. Controlled filtering method which makes sure that soil is at correct moisture content to achieve maximum compaction. It's a very important point to you. You have to ensure moisture content of fill material. Soil modification. This means if there is a different type of moisture content, different percentage, you can bring it this error. Soil modification is process of creating a controlled filtering method which makes sure that soil is at correct moisture content to achieve maximum compaction. structural earthwork, structural works have been carried out successfully for many years. However, maximize land value to maximize land values or realize land investments, many sites reprofile to meet required design levels for all new development. Therefore, it makes sense to use site one fill materials and place them in controlled manner, which avoids to take required foundation loading back down through upfill materials and onto them. Now it is to increment weather means there's likelihood that soil will always be in excess of their natural optimum content, or shall become in excess of their optimum point. So considering climatic conditions and its soil conditions, climatic conditions and relevant soil conditions, or impact of those climatic conditions, soil conditions, and given there is no accurate method to control site one soil moisture content, clients face a real challenge to meet requirements of high performance density driven specifications, especially when industry requires standards max minimum 95% compaction and less than 5% air voids for many high end performance situations such as under building foundations. Now, successfully using soil modification technique as an effective means of gaining control of soil moisture content during course of undertaking structural earthwork operations. This fill drying technique has been proven to achieve required density driven specification, and it has made requirements of engineers, clients and insurers on various projects. Alright, now see successful soil modification technique. Advantage of this modification, it conditions non-engineered materials to an appropriate engineered solution, high strength fill materials with minimal settlement or swell, engineered backfill ready for pad, stiff foundation and ground bearing floor slab. Reduces need for deep foundation works, imported stone, mass concrete or massive concrete and piling. No requirement for stone capping layers on roads, car parking areas, etc. Creates a capability to recycle on-site materials, thereby reducing material going off-site and decreasing aggregates coming back on site. And now, it conditions we have known, it conditions non-engineered material appropriate engine solution, high strength fill material minimum sulfur well, engine backfill ready for road bed, stiff foundation ground beam, road slabs, reduces the need for deep foundation works, imported stone mask, applying no requirement stone capping layers on roads, car parking areas, creates the capability to reduce cycle on-site material, thereby reducing material going off-site and decreasing aggregate coming back on site, and reduces environmental impact through better use of existing site materials. Applications virtually orthodox project where there is a desire to maximize reduce use of site one soil and minimize cost of foundation solution for building the roads. And now why is that? Say soil intended for modification may be treated either in situ or in cut area. Now say soils intended for modification may be treated either in situ, in cut area prior to excavation and deposition as fill elsewhere on site, or alternatively in situ. Alternatively in situ once placed in a control layer thickness in fill situation. There are merits to each approach, and this should be determined on a project specific basis. However, it's critical that adequate grading affects to ready materials for stabilization, because you must make sure that materials are treated in control layer thickness, and this allows us to check that all materials are treated to required degree without thin laminations of untreated material between layers. I repeat this is a good one. Soils intended for modification may be treated either in situ in cut area prior to excavation and deposition as fill elsewhere on site, or alternatively in situ once placed in a control layer thickness and fill situation. There are merits in each approach, and this would be determined on a project basis. However, it's critical that adequate grading affects to ready materials for stabilization, because we must make sure that materials are treated in control layer thickness, and this allows us to check that all materials are treated to same required degree without their thin laminations of untreated materials layers. Required dose of proprietary dry binder is then spread over materials which are undergoing treatment using computer controlled binder spreader. We operate a fleet of modern self-propelled spreaders which offer a higher degree of accuracy and minimize production of airborne dust during process. Like of quantity of binder that's required for each project is determined through initial design testing, and that's normally carried out prior to start, and then on an ongoing basis to allow for variations in ground. Most commonly used binders are hydrated quicklime and cements, but others such as pulverized feathers, then you can say after that, so it says the type and quantity of binder that is required for each project is determined through an initial design testing that's normally carried out prior to site start and on an ongoing basis to allow for variations in ground. Most commonly used binders are hydrated quicklime and cements. Other such as pulverized fuel as PFA and ground granulated blast furnace / DGBS may also be used depending on requirements for each project. Mixing takes effects to incorporate binder into soil. Our preference is to utilize one of high efficient self-propelled stabilizing machines. Although our fleet also includes the tractor mounted variant for using small sites and lighter soil conditions to ensure we can deliver exactly what our client need. In certain circumstances, such as when working in heavy clay type soil, secondary mixing may also be required to achieve correct degree of pulverization. In these cases, materials are graded to ensure correct layer thickness is maintained, compaction then compacted with a specified number of passes by heavy soil compactor. Process is repeated for subsequent layers until required design level is attained. Throughout process, our dozers and excavators use GPS technology to ensure that we accurately control layer thicknesses, ensure that no area of fill is overcut or developed. And that's end of this file, and I'll see if we can do next file. Your time this, and that is about 10-15 minutes. Let me see if I can open that. And that is vibro stone columns. Maybe you know about that. Vibro stone columns. Vibro stone columns and vibro stone columns are one of most commonly specified ground improvement methods everywhere. Particularly given correct soil conditions, they can provide a relatively inexpensive and quick method of ground improvement. They can be used to provide an increase in bearing capacity and to improve settlement characters. In certain instances, they can also be used as an alternative to more expensive pile foundations for lightweight structures. Most commonly, GDL offers stone columns in conjunction with structural works, the structural earthworks utilizing soil modifications. Again, I am saying why stone columns, one of most commonly specified ground improvement methods. Given correct soil conditions, they can provide relatively inexpensive and quick method of ground improvement used to provide an increase in bearing capacity and to improve settlement characteristics. In certain instances, can also be used as an alternative to more inexpensive pile foundations for lightweight structures. Most commonly offer stone column conjunction with structural works. Now, layout of vibro stone columns are arranged to suit specific applications. Columns are positioned under load lines of foundations or in on a grid pattern under floors and outlet. Result is an interaction between stone column and surrounding soils. Together, stone columns and confining soils provide a composite ground improvement with enhancing bearing capacity and layout of vibration columns are arranged to suit specific conditions. Columns are positioned under load lines of foundations and patterns. And technical data columns, you can say columns diameter 600 mm, 2 feet, 600 mm, column depth up to 8 meter depending on soil consistency. Application of foundation solution for lightweight structure, industrial warehouses, retaining walls, reducing pore water pressure on cohesive soil. And I'll just give a photograph of this. I'll give you a photograph of this. Yes, that's the indicator sketch it is, so it's not a problem. I can give that one, and then I close this talk today. So. I'll take this. Let us see how to. I'll take this down here. So I have taken the photograph and I'm using stone columns now. All this. Stone column I'm showing to you. This is stone column here. So this is a stone column file. I actually try to communicate to you about soil improvement methods. Soil improvement is very important part in engineering, particularly in those areas where bearing capacity is too low. We cannot do that. It's very important one that we have to. No, it's not that. It's not that, Purpose of I was actually continuing with my book one, but because I got these files after searching internet yesterday, I wanted to include this in today's talk if possible, and I've been successful actually to include all these 6 files or 7 files, whatever number of files are here. It's good that I could, but explanation still remains. We'll see how it works. It should work better than before. Soil improvement is very, very required one. You can't go without this. As we discussed before about this improvement. When I was talking from this textbook, referring to textbook yesterday, we'll discuss a lot on that. Textbook, and we conclude even your cement stabilization. We're talking of method of mixing and mixing place methods. We're talking of traveling plant method, etc., etc. We talked of that. Lime stabilization also we had to be continued. Bituminous stabilization, etc. No flies. All this we have to continue still. It's not finished here. But this was sandwich introduction, sandwich references I had to give in this. So bloody don't send your photos here. Why are you sending your photos? It's disturbing me. They don't understand I'm doing something or concrete and they're this in their photos. Yeah. When it is, we had gone to this area, how we had particularly talked yesterday about how to mix 2 or 3 different kinds of fill materials when we don't have good fill materials with us, means our site excavated matter doesn't suit our material, our requirement, and we have to import aggregates from outside, or you can say certain different kind of fill materials from outside, and we have to mix different 2 or 3 or 4 types of mixture to get certain, our expected requirements. That process we discussed yesterday, and that was there. We had talked of this at length yesterday, and after the cement stabilization was this cement stabilization. Now actually exactly cement alone cannot be used, you can say, yet I will read it again. What's written in this: cement has been used successfully to stabilize granular soil sands, sites, and up to medium plastic clays all over the world. Several thousand miles of soil cement roads have been constructed, and major constituents of cement which have distinct effects on strength aspects of soil cement mixes are calcium disilicate, calcium trisilicate, free lime calcium trisilicate sets fast and is responsible for immediate strength gains. Free lime may bring about base exchange capacity and change in texture of soil. This may also contribute to long-term positive reaction. Calcium disilicate is responsible for long-term strength due to hydration reaction. In case of granular non-plastic soils, non-plastic NP soils like granular soils, cement may bind particles at point of contact. However, in case of fine-grained soil like clay, particles of soil or aggregate from a mix of soil cement with cement, as cement partly coats agglomeration prevents water from attacking clay particles. Adequate amount of cement, proper amount of moisture, high compaction, and good curing are important for obtaining a good compacted strong soil cement mix. The strength of soil cement increases with increasing amount of cement. If a soil contains too much organic material or sulfate, cement would not produce proper strength. Now what actually we have added to this method of mixing is something else I'm going to later on, but today I have to this cement stabilization I added because this is old one, very old one, and this doesn't suffice with what actually we have to do. There are materials, more materials than this, which are waste materials, you say, waste materials from, you can say, power plants like fly ash, PFA, and RHA, the rusk, and from plants, that is a waste, and also GGBS. So we have 2 materials, and that is one is pulverized fly ash and GGBS. Both are important material which can be used for soil stabilization, and these are in addition to cement alone, because cement alone doesn't work these days. Every cement is with PFA percentage or GGBS, and more important, combination of cement with PFA and GGBS that's required. We have talked of that in these submissions, in these presentations from literature, that it was better and up to 9% GGBS you can achieve best moisture content, you can achieve best properties at GGBS 9%. And there are so many other graphs are shown, talks are made. So there are various ways that we can even reduce, you can say, we can reduce liquid limit, and we can reduce plastic limit, and we can say plasticity index, I'm sorry, and then there are three limits we can say in Atterbuck's for clay soil, for cohesive soils like the liquid limit, plastic limits, shrinkage limits. There are three limits, and there's a plasticity index that you can say, which is difference of liquid limit and plastic limit. Liquid limit is higher always, plastic is lower generally. We have to keep both lower, because if you increase water contents at liquid level, all will flow, there is no standing soil, and if you take out water from that, liquid limit is down, this means it will be a plastic material. And if you take further down and down, the leaves you get to your shrinkage limit. Shrinkage limit means from that downwards it would be semi-solid and solid. These are various limits in Atterbuck category for purpose of engineering. There are so many limits. Others there is no concern with that. So Atterbuck, which is a German scientist, he discovered all this, and we are using these three limits particularly, which say liquid limit and plastic limit and shrinkage limits for purpose of cohesive soils. That's clay soil. It's important not for granules, not for purpose of granules. I'm talking about these soils, which are, you can say, these are very important soils. We should not miss them, because generally you find black cotton soils and clay soil on all areas all over, and not particularly many areas in our country as well as in England, for example, they were talking about that, or maybe many areas in, you can say, Africa, or in a USA, and not in Gulf exactly, I can't say. Iraq is there, Iraq, yes, probably I don't know about Iran, could be there also. So those soils we have to improve, because those soils are expensive soils, they don't have shear strength in them, very good shear strength, they can't take, and these are cohesive soils, there is no relation to bearing capsule with them, bearing is used for only granular soils. So we have different type of soils here. We have to understand what is the relation to each soil. It's granular soil is there, then cohesive soil is there, then lime soil is there, then you can say peat is there, and many other soils are there, which understanding is very important to develop for civil engineer, for an engineer working in field of structures. Otherwise, you have to design foundation. If somebody shall give you information, you say, oh, this person gave me information about soil and I am using that information. So you are not understanding soil report. You are using recommendation exactly what somebody else gives, but that person may not be very experienced. So it's very important for civil engineer, for structural engineer to understand soil first. You can design foundation, not a big issue, there's a calculation, but problem is foundation is resting on a material that is natural material. It does that natural material meet requirement, or you have to make it further better? That is a question mark. That question mark we have to understand in kilo terms. Only then we can say we have reached our goal. Otherwise we sit like, as if we depend on someone else for everything. Therefore, I just try to put in some sandwich information, which is updated one, including GGBS, including PFA, including many other materials, and you can say lime stabilization, cement. This is very old theory. Lime and cement is very expensive. You can't use always. People don't understand this point. And there are maybe many more points coming in. We'll take up later on. This was just I put in today, and I also could not touch FIDIC today again. Tomorrow I'll partition. I think it's not possible to go there, because in between I felt that there's a need for soil engineers learn this. They're missing something, and they're missing everything. Just designing by software is one part of work. Of question is understanding material. If you can't understand material, you can't decide. You can't take engineering judgment, which you require to take. And if you don't take engineering judgment based on your study, you would say, I have taken information from other person, which doesn't mean you can't take responsibility. You have to ensure other person is used to write same reports all the time. They don't understand what is in your mind. They depend on boreholes, say some boreholes they attend upon information, and that role may not be adequate because there are some plate load bearing tests or some other tests. We have to understand those reports very well. Only then we can do that. Otherwise, we can't answer that. So with this, I will try to close this today, of course. And I think people may like to have interest in these talks if they are interested to understand soil, because soil is very boring subject. We know concrete is not boring, soil is boring. Block masonry is not boring, soil is boring, because soil is not directly seen. There is no direct design on soil. Soil is based on experiments, soil is based on testing, soil is based on laboratory tests or on site tests, which we are not there at that time. We don't witness them, and reports are there. We have to depend on reports, and if you are to witness them, you have to spend a lot of time in laboratory, which you don't have. So you can go for cube test for half an hour. You could do that. You can go for core test. You could do that. But for this soil, at that time you are not there. Pre start of project is soil investigation, and during project start there's no investigation. Virtually should also be done. So there is no chance for you to stand with that. That's personally theoretically we have to understand. We have to understand based on information that we have. I tried to search a lot on internet. I could not get very much information, to be very frank. It's not extensive information available on internet. This means there is a scarcity of this information. If there is scarcity of something, we have to understand. People say go to books. I am going through all professors, never cite experience. So how can you depend upon their knowledge, which is not linked to practical angle, practical aspect of life? So with that, I close this, hoping you will understand well, and I close this for current, and that's I am closing YouTube first, and this is closed, and the stream and YouTube has gone now. I'll close this, and I'll come back to this one, and I'm also closing this. Thank you, Mr. Dehas Lausen, for your participation, for your joining, and that's it. Think close.